Scientists just discovered a lake in Antarctica that flips everything we thought we knew about life on Earth. They drilled through thick ice and found liquid water where everything should be frozen solid. And inside this water, there is life. I mean actual living organisms thriving in the dark, untouched for ages. The story starts with an expedition that added a new, super important spot to the Antarctica map. Between November 2019 and January 2020, researchers trekking across the frozen desolation reached an area called Enigma Lake. They thought they were walking over a huge slab of solid ice, but their gear showed something different. So they used a powerful drill to get through the ice, peered beneath layer after layer, and detected at least 40 feet of liquid water trapped under the surface. They came looking for a rock, but found a hidden world under ice in this Antarctica lake, where they would least expect it. The scientists were shocked and didn't stop at this discovery. They wanted to know where all this water came from, because in this part of Antarctica, the climate is ruthless. Extreme temperature, low precipitation, punishing winds, and solar evaporation aren't exactly perfect conditions for a lake. Any fresh water was supposed to have dried up long ago. So there had to be a source for refills for a subglacial lake in Antarctica like this one. The researchers looked at the chemical composition of the salts and dissolved materials in the water. They noticed some patterns that pointed to a source. It looked like the nearby glacier was feeding the lake via some underground pathway nobody expected to exist. So there it is, an amazing Antarctica discovery hidden beneath ice, fed not from rain or surface melting, but from an underground flow that circles the Earth in silence. And because of that, when the team drilled deeper, they didn't just find water, they found a secret ecosystem. Life, where they thought there couldn't be any. Now by life here, I don't mean the kind that waves at us. I mean tiny creatures, tiny structures, microbial communities that evolved in isolation, shielded by the ice, and pretty restricted to their hidden home. They cover the lake bed in microbial mats, not just blobs of algae, but complex, carpet-like mats of microorganisms. Some mats look like thin, spiky coverings, others like thick, crumpled carpets, or even tree-like structures up to 15 inches tall. And these formations, looking straight out of a sci-fi movie about life on distant planets, aren't random specks of DNA floating in water. They are thriving, building structures, layering, changing over time. So the lake bed is kinda like a forest floor, only it's dark, cold, and covered by ice. If life can flourish under 45 feet of ice in near darkness, maybe our ideas of where it can exist need updating. And we don't know what happens when we disturb this hidden lake ecosystem. What if we inject humans, machinery, or even our breath into the mix? These microbes have lived isolated for who knows how many millennia, maybe even millions of years, without any exposure to the world above. If humans mess with them, these organisms could be at serious risk when they meet microbes they had never met before. The lake could get contaminated, and its ecosystem could change for good. As we step into this new territory, we must be extra cautious. After all, the entire Antarctica is like a book of secrets of evolution, adaptation, and survival that we must read carefully. This continent keeps surprising us. Animals that were never seen before turn up in its remote corners, from bizarre sea creatures to ice-loving insects you didn't know existed. For example, the ice-loving sea anemone scientists spotted hanging upside down from the underside of the Ross ice shelf. It looks like a delicate flower glued to the ceiling, waving its tentacles into water as cold as a bad breakup. Researchers steered a robot under the ice and found a brand new species. Then there's the celebrity newcomer with serious red carpet energy, the Antarctic strawberry feather star. This floating pom-pom can have up to 20 arms. It got its nickname because the body looks, you guessed it, strawberry-ish. And oh, I guess Antarctica is the last place where you'd expect to see a fish nursery, but it has the largest known one in the whole world. Researchers were there towing their cameras along the Weddell Sea seabed to map it when they spotted thousands, then millions of identical bowls in the sediment. The nests covered 93 square miles of seafloor, and there were a total of 60 million of them, one every 10 inches. All the nests belonged to icefish. These creatures are white-blooded, meaning they don't have hemoglobin, the stuff that makes blood red, and somehow they still manage to survive in water cold enough to shatter your soul. Every nest had a parent fish sitting guard over about 1,700 eggs. Turns out, Weddell seals feast on icefish, so this massive breeding ground isn't just a nursery, it's also a buffet for the neighborhood predators. And speaking of buffets, the icefish themselves feed from a warm upwelling that pulls up nutrients and microscopic zooplankton. It's all pretty cool that the icefish colony has a hard edge, a literal line in the sand. The edge of that border matches perfectly with the outer rim of the warm upwelling, which looks like a carefully crafted evolutionary trick. Another Antarctica discovery that shocked scientists wasn't a cool-looking fish or a dinosaur bone, but something probably even more important for science: bubbles. Tiny ancient bubbles trapped inside what might be the oldest ice ever brought up to daylight, nearly 1.2 million years old. Before this discovery, researchers had recorded climate history going back 800,000 years, but they wanted more. They spent years searching for the perfect spot where ice could tell the story straight through. Some Antarctic regions hold ice even older, maybe 3 or 4 million years. But it's patchy, and they needed a continuous record. When they finally drilled into the right spot, they found crystal clear ice cores with bubbles that trapped the atmosphere of Earth as it was hundreds of thousands of years ago. When scientists analyze the air inside, they're not just studying gases. They can tell what our distant ancestors inhaled, what the planet exhaled, and how the rhythm of life and climate played out long before us. The period around 900,000 years ago, the same time sealed inside this ice, may have been one of humanity's closest calls. According to genetic studies, the human population shrank to about 1,300 individuals on the entire planet. Nobody knows what exactly led to this, but it could have been the climate. So these ancient bubbles might hold the clues we need to understand how our ancestors survived one of the toughest chapters in Earth's story. And maybe how we can survive the next. Because the planet keeps repeating itself in new and uncomfortable ways, and Antarctica has lessons to teach us. One lesson we might learn the hard way has to do with what's under its ice. Scientists recently found that there's something brewing beneath Antarctica that's anything but chill. There might be volcanoes there, quietly waiting for their moment. Yeah, you heard it correctly. Volcanoes, the hot, fiery kind sitting under miles of ice. The team used computer simulations and found that when parts of the ice melt, the pressure holding those volcanoes down eases up. And boom! They could start melting even more ice from below. It's like a self-feeding loop of chaos. The ice melts, volcano wakes up, then more ice melts. Even if humans stopped affecting the climate conditions on the planet tomorrow, that chain reaction could keep going because it's not just about the air. It's about the fire hiding underneath. The scariest part is that this kind of melt could raise sea levels way more than we thought. And since Antarctica has over 70% of all the freshwater reserves on Earth, you can imagine the drama level it could lead to. So you see now that Antarctica map is like a real-life board game for humans, and we must be careful studying and playing it. Stop for a second and look at the ground beneath your feet. Is it a quiet suburban street, a flat basketball court, or maybe a peaceful stretch of farmland? You probably feel safe because there isn't a giant smoking mountain on the horizon, but that safety is an illusion. Yeah, sure. Yellowstone, Vesuvius, or Mount Fuji, those are the celebrities of the geological world. Giants that dominate the skyline and sometimes blow their tops. But what about a hidden threat? One that doesn't look like a volcano at all. It's invisible, it's silent, and thousands of these traps are scattered across the planet, lurking right under the foundations of our biggest cities. Scientists call them monogenetic volcanic fields. To the untrained eye, they don't look like volcanoes at all. They disguise themselves as innocent hills, flat plains, or just lovely lakes. For decades, they were mainly ignored because of their small size. But new data suggests these hidden systems are far more dangerous than previously thought. And unlike the big giants that give weeks of warning rumbles, these invisible volcanoes specialize in surprise attacks. Hold tight. To understand the danger, we have to look at the plumbing. A standard volcano acts like a simple chimney. There is a central magma chamber and a main pipe leading to the surface. Eruption after eruption, lava flows out the same vent, building a massive cone over thousands of years. Monogenetic fields break all these rules. They don't build mountains. They don't reuse the same pipe. Instead of a chimney, imagine a cracked windshield. Magma deep underground scans for any weakness in the crust over a massive area. It pushes up, cracks the surface, erupts once, usually violently, and then calms down forever. The next time magma rises, it won't use that old vent. It will find a new crack 5 miles away, or 10. This means you can't just monitor one specific mountain. The entire region is a danger zone. And because each volcano is a one-and-done event, the landscape is deceptive. You could drive past a site of a violent ancient explosion every day on your way to work and simply see a grassy knoll. The scary part is the speed. In these fields, magma can rocket from 30 miles down to the surface in less than 24 hours. It moves at a speed of up to 4 miles per hour. That sounds slow for a car, but for melting rocks, that is the speed of an elevator. This isn't just a theoretical problem for empty deserts. Take Auckland, New Zealand. It's a stunning modern city with beautiful harbors and over 1 million residents. But Auckland is built directly on top of a geological minefield. Sounds a bit crazy, right? Beneath rugby stadiums, parks, and busy intersections lies the Auckland Volcanic Field. Those scenic green hills scattered across the city aren't just landscaping. They're the remains of over 53 separate volcanic eruptions. Rangitoto Island, which sits just offshore, emerged from the ocean only 600 years ago. In geological time, that was 5 minutes ago. For years, this field was considered sleepy, but recently, scientists have started noticing subtle changes. The terrifying reality of a field like this isn't that a volcano we already know will erupt again. It's that a new one can pop up and go from zero to a disaster in the blink of an eye. A bubble of magma could rise silently beneath a factory, a highway interchange, or a residential neighborhood. There is no designated safe zone because the threat is spread across the entire city map. History gives us a brutal example of how fast this happens. In 1943, a farmer named Dionisio Pulido was plowing his cornfield in Mexico, on the outskirts of Mexico City. It was a normal Tuesday. Suddenly, the ground cracked open right in front of him. Smoke hissed out, smelling of rotten eggs. Within 24 hours, that small crack in a flat field had transformed into a raging volcano 160 feet tall. Within a week, it stood 500 feet high. This was the birth of Paricutin. It wiped out 2 entire towns, leaving only the stone steeple of a church poking out of the hardened lava, a haunting monument that still stands today. This geological nightmare started in a simple cornfield, and it wasn't an isolated incident. Look at the Harat Rahat field in Saudi Arabia. In 1256, a massive fissure opened up near the city of Medina. It spewed lava for 52 days, creating a river of fire 14 miles long. Today, that same volcanic field is still there, and modern Medina has expanded right on top of the ancient lava flows. Now, apply that same story to a suburb of Los Angeles, a district in Tokyo, or a neighborhood in Europe. In a matter of days, an entire city can be buried under ash. The risk is global, ranging from over 1,800 vents in the American Southwest to the restless Eifel region in Germany and similar fields in China. Experts warn that the real risk here isn't size, but frequency and location. These volcanoes tend to be explosive. When magma rises rapidly and hits groundwater, which is common under cities and fertile farmland, it flashes into steam. This creates a phreatomagnetic explosion. Instead of a slow, oozing river of lava that people can walk away from, the ground acts like a shotgun blast. It sends a massive column of ash and rock shooting into the atmosphere. In our modern world, this is a recipe for chaos. We rely on delicate systems, air travel, GPS signals, just-in-time supply chains. You don't need a supervolcano to crash the global economy. A small eruption near a major logistics hub is enough. Remember the 2010 eruption in Iceland? That wasn't even a big explosion by historical standards. Yet, the ash cloud grounded over 100,000 flights, and 10 million passengers were stranded. Volcanic ash melts inside jet engines, while toxic dust poisons crops and contaminates water reservoirs with heavy metals. It creates a domino effect. One small eruption in the wrong place triggers a cascading failure of global infrastructure. And the most alarming part is that the signals are already there. Recent geological studies have shown an uptick in activity in these distributed fields. It isn't always violent earthquakes. Often, it's bradyseism, the slow rhythmic breathing of the ground. We mentioned the Eifel region of Germany, where GPS data shows the land is rising by about 0.04 inches per year. It sounds tiny, but for geologists, that is a proper red flag. Scientists are detecting slight swells in the Earth's crust and weird spikes in carbon dioxide emissions in places that should be quiet. Magma is moving, but because these systems are so spread out, monitoring them is a nightmare. We have sensors all over Yellowstone. We watch Vesuvius 24/7, but almost no one is watching a random patch of desert in Arizona or a forest floor in Germany. These invisible volcanoes are poorly studied. We lack the baseline data to know if a tremor is just a truck driving by or the start of a Perikutin-style event. This lack of data means that when an eruption starts, authorities might have almost zero warning. In a polygenetic volcano, the mountain swells for months. In a monogenetic field, magma can shoot from the deep mantle to the surface in hours. By the time the evacuation order is written, the lava could already be breaking through the pavement. It isn't that hard to imagine the logistical nightmare. A city not known for volcanoes suddenly receives an alert. A vent is forming downtown. It sounds impossible. People delay leaving. They grab their phones to film the smoke. Then, explosions start. The ash creates a blackout. Power grids fail as wet ash shorts out transformers. Roads gridlock instantly. This scenario isn't science fiction. It's exactly what hazard models predict for places like the Auckland Volcanic Field or parts of the Trans-Mexican Volcanic Belt. We are building denser and denser cities on top of geological landmines. This doesn't mean we need to start digging bunkers, but it does require a shift in perspective. We have spent so much time worrying about the celebrity volcanoes that we forgot about the quiet ones. The Earth is a living, shifting engine that doesn't care about property lines or city limits. Scientists are now pushing for better monitoring networks, using satellites to track even the tiniest ground deformation in these boring, flat fields. Because the only way to survive a surprise attack is to see it coming before the ground cracks open. Peace and quiet on the surface doesn't always mean peace and quiet underneath. The Earth has plenty of secrets left, and some of them are just waiting for the right moment to surface.
So, what do you like to listen to? Music? Podcasts? Maybe the sound of rain or the crackling of a campfire. But what about listening to the ocean? Not the familiar crash of waves on the shore, but sounds captured deep on the cold ocean floor. Sounds that send chills down your spine. Sounds of something big, dark, and possibly alive. And the most unsettling part is this. The true nature of some of these sounds remains a complete mystery to this day. In 1997, something strange echoed through the Pacific Ocean. Deep beneath the surface, far off the coast of South America, a sound appeared so powerful that it instantly unsettled scientists. It was ultra-low in frequency, massively loud, and unlike anything recorded before. The signal was later given a simple name: the bloop. At first glance, the bloop sounds harmless, almost playful, but what it represented was anything but. It was so intense that it could be detected by sensors nearly 3,000 miles away. Imagine standing in New York and hearing something happening in Los Angeles. Now imagine that noise travel through deep ocean water, terrifying marine life and oceanographers. Whatever produced it had to be enormous. The signal carried patterns that felt like its source was some living creature. Whales were the first suspects, but even the blue whale, the largest animal in the world, simply couldn't generate a sound that loud. The numbers didn't add up, and that's when speculation took over. If something could produce the bloop, it would have to be larger than anything swimming in today's oceans. People began imagining creatures of impossible size, ancient sea monsters, the kraken. Some even whispered about the megalodon, a prehistoric giant shark thought to have gone extinct millions of years ago, and featured in dozens of videos right here on the bright side. The mystery only grew deeper when scientists mapped the approximate location of the sound's origin. It came from a region close to Point Nemo, the most remote place on Earth. This spot in the Pacific Ocean lies more than 1,000 miles away from the nearest land in every direction. It's so isolated that it's often called the oceanic pole of inaccessibility. Point Nemo is a place few humans will ever see. Because of its remoteness, it has become a kind of graveyard for defunct satellites and space debris. When spacecraft are decommissioned, they are often guided to fall into these waters. It's quiet, empty, almost untouched, and yet something powerful had screamed from nearby. For fans of cosmic horror, this detail felt oddly familiar. In the fictional universe of writer H.P. Lovecraft, the ancient sunken city of R'lyeh lies beneath the ocean near this very region. According to the stories, R'lyeh is where the monstrous entity Cthulhu sleeps. It's a powerful, scary, intelligent creature, lying dormant for thousands of years, ready to awaken and bring about the end of the world. Of course, Cthulhu is pure fiction. Lovecraft never claimed otherwise. But once the internet made the connection, the idea took on a life of its own. But science eventually caught up. The bloop recording is still easy to find online. You can listen to it yourself. But it sounds so innocuous that you'll probably be disappointed. And today, we know with certainty that it didn't come from a living creature. Researchers later confirmed that the sound was produced by ice, specifically by an ice quake. Now, ice quakes occur when enormous icebergs fracture, crack, and break away from glaciers. When this happens, they release tremendous amounts of energy, generating ultra-low frequency sounds that can travel across entire ocean basins. These sounds are similar to biological calls, especially when recorded from far away and distorted by water. In fact, scientists compared the bloop to other known icequake recordings and found striking similarities. The source wasn't a monster. It was Antarctica itself during shifting, breaking, and reshaping. For many people, this idea brought mixed emotions. On forums like Reddit, some openly admitted they preferred the idea of a giant unknown life form. Yup. Another strange sound was captured in the early 1980s, deep in the South Pacific, during a scientific expedition near New Zealand. Researchers were exploring the South Fiji Basin, where the ocean floor lies more than 2.5 miles beneath the surface. There were short, sharp, repeating noises echoing through the water. 4 distinct bursts, each one sounding uncannily like a duck's quack. So researchers called it the bioduck. The sound was rhythmic and consistent. Eventually, the team concluded that the source had to be biological, but identifying exactly what made the sound proved impossible. After sharing the data with colleagues in Australia, did they realize something even stranger? Similar sounds had been recorded in other parts of New Zealand and Australian waters. Decades later, the mystery remains unsolved. Some scientists believe the quacks may not be random at all. They could be a form of communication. Perhaps the sounds may come from Antarctic minke whales, though no direct proof exists. Scientists also noticed that there were several sources of sounds, and when one source spoke, the others fell silent, as if they were listening. It may have been a conversation echoing through the deep, in a language we still don't understand. Imagine a terrifying alarm blaring inside a secret laboratory. announcing that a monster from another planet has broken free. It's an ugly sound, loud, piercing, and oppressive, the kind that makes your skin crawl. In August of 1991, scientists recorded something eerily similar. Not in a lab, but deep beneath the Pacific Ocean. Across vast areas of the ocean, a strange, repeating signal began to appear at different times. It consisted of narrow, rising tones that lasted several seconds each. Researchers named this sound Upsweep. It's detected most often during the spring and fall, leading scientists to believe it may be connected to seasonal environmental changes or changes in the source itself. But what exactly was producing it? No one knows for sure. The only thing scientists can say with confidence is that Upsweep appeared near areas of suspected volcanic activity. But if this sound is natural, why does it seem so precise? So consistent? It almost feels artificial, as if a secret underwater facility is periodically broadcasting a distress signal from the depths of the ocean. Since its discovery in 1991, the Upsweep signal has gradually weakened, making it one of the strangest and most unexplained phenomena ever recorded beneath the ocean. Now, there's another mysterious sound known simply as slow down. True to its name, this signal steadily decreases in frequency over 7 minutes before fading into complete silence. It was recorded in May 1997 on a hydrophone array located in the eastern equatorial Pacific Ocean. At first, slow down doesn't seem especially loud. But here's the chilling part. It was picked up by 3 separate sensors placed nearly 3,100 miles apart. Imagine how deafening and terrifying it was near the source itself. So, what caused it? The most widely accepted theory suggests that a massive drifting iceberg slowly came to a stop and ran aground. The idea is surprisingly plausible. A colossal block of ice is scraping along the seafloor, grinding forward until it finally halts. The location supports this theory as well, since the sound originated near shallow waters and small islands. Because of this, many scientists classify slow down alongside the bloop as a cryogenic noise caused by ice. Still, it remains just a theory. Officially, the sound has never been identified. And there's yet another eerie recording from the ocean. This one sounds like a moan, but scientists named it whistle. Go figure. It was recorded in 1997 and gives the unsettling impression that something enormous is sitting on the ocean floor and whistling. Researchers believe that something could be an underwater volcano. When they compared the whistle signal to previously recorded volcanic sounds from the Eastern Pacific, they found them very similar to each other. Most likely, all these sounds are of a natural source, volcanic eruption or iceberg collision. But it's still pretty scary to hear something like this while driving. It would be especially unpleasant to be directly above an erupting underwater volcano. Well, yeah.
Tiny microbes, basically ancient germs, have been frozen in Arctic ice for tens of thousands of years, just chilling there, since woolly mammoths were still walking around. And now, scientists think these little guys might wake up again if Arctic summers keep getting longer and warmer. Yep, you heard right. Zombie microbes. Great. These microbes have been stuck in permafrost, which is soil and ice that stays frozen solid year-round. The top layer melts a bit in the summer, but the really old stuff, those Ice Age microbes, are buried way deeper. They only thaw if things get really warm for months, not just a hot day or two. To study these microbes, the team went down to the permafrost research tunnel near Fairbanks in Alaska, a long underground hallway 50 feet below the surface, carved right into the ancient frozen ground. The tunnel stretches over 350 feet and lets scientists literally walk through thousands of years of frozen history. By the way, while checking out the walls, the researchers also spotted bones of mammoths and bison sticking out of the ice. One of the reasons why the researchers went to Alaska was to see how fast these ancient microbes could come back to life. Well, they were in for a surprise. These microbes don't need years, centuries, or magic spells to wake up. Just a couple of months of warm weather. Once they're awake, they start doing their microbe stuff, which includes pumping out greenhouse gases like CO2 and methane. And that's bad news, because those gases warm the planet even more. This melts more permafrost, which wakes up more microbes, which releases more gas. You get it. Basically, it's a nasty climate loop. Anyway, when scientists went down into the frozen tunnel to grab chunks of super old permafrost, the first thing they noticed was the awful smell. It wasn't just the stench of an old basement. It was something has been frozen for thousands of years and is finally waking up bad. Weirdly, microbiologists were happy. Such a smell is actually a good sign for them because it usually means tiny creatures, microbes, are still around. Back in the lab, the team soaked the frozen samples in the water that had a special kind of heavy hydrogen inside it. This helped them track what the microbes were doing later. Then they put the samples into fridges at 3 different temperatures: cold, kinda cold, and not too cold, to copy what future Arctic summers might feel like if the warming continues. For the first month, almost nothing happened. Even the warmer samples barely changed. Only a tiny number of microbes started waking up. Basically, a microscopic trickle of activity. But a few months later, things got more exciting. Thanks to the heavy water, scientists could watch how much of it the microbes used to build their cell membranes. It helped them figure out that the old microbes were making special fatty molecules that might help them stay alive in freezing conditions. By the 6-month mark, the samples that were stored at the warmer temperatures had transformed completely. They became more active and started forming little slime layers. The scientists could actually see these layers even without a microscope. The whole community of microbes wasn't super diverse, but those that were active behaved just like modern microbes that live in unfrozen soil today. In short, those ancient microbes were definitely alive and got pretty energetic once the temperatures were warm enough. This matters a lot for the Arctic and for the whole planet, because these microbes survive by eating old organic material trapped in the permafrost. When they eat, they release greenhouse gases like carbon dioxide and methane, and the Arctic is warming faster than any other part of Earth. It means that the deep frozen layers might stay warm long enough for huge numbers of ancient microbes to wake up and start pumping out gas. Right now, northern permafrost holds about twice as much carbon as the entire atmosphere. If a lot of that carbon gets released, it could speed up the warming of our planet. It can lead to dramatic consequences, setting off a whole chain of huge changes and affecting basically everything on Earth. Extreme weather will start happening more often. Stronger hurricanes, heavier rainstorms, longer heat waves, bigger wildfires. The oceans will rise too, which can flood coastlines and put towns and cities at risk. Animals, plants, and entire ecosystems can get thrown out of balance, with some species struggling to survive and food chains breaking down. People all over the world will have to deal with crop failures, water shortages, and damaged homes or infrastructure. Let's get back to our zombie microbes. The thing is, the study only looked at them in one place in Alaska, but there's a massive amount of permafrost all over the world, in Alaska, Canada, Siberia, and many other places. And microbes in different regions might behave differently as things warm up. Scientists still have tons of work to do to figure out what's coming next. I bet you're questioning yourself. Could ancient viruses infect us? Well, most of the ancient microbes frozen in permafrost are totally harmless. They're like old bacteria that only care about messing with other tiny organisms in the dirt. But scientists worry that a few of these frozen germs might be the kind that can infect people, animals, or plants. And if that happened, our bodies probably wouldn't recognize them at all, because they've been frozen since mammoths existed. Basically, there's no immune system cheat codes for us. The risks of this happening grow for a number of reasons. For one thing, the Arctic is warming almost 4 times faster than the rest of the planet. Longer summers plus hotter temperatures mean more permafrost melting. So, more ancient stuff is waking up. Plus, people might start digging more around there. Companies will mine more, drill for oil, and ships can travel new routes. All this activity tears open ground that used to stay frozen solid. This increases the chance that someone or something comes across some ancient germ that just woke up. What would actually happen then? We might run into different zoonotic diseases, basically germs that jump from animals to humans. This already happened once. Thawed reindeer carcasses released anthrax, a rare and serious illness which then infected people and animals. Luckily, we do know how to treat anthrax. But what if something even older wakes up? Besides, our immune system might have zero defense. If a virus hasn't been around for tens of thousands of years, humans today would be like, what is that thing? No antibodies, no memories of it, nothing. But the scariest part is that we don't know what's hiding down there. Scientists think permafrost might be storing trillions of frozen microbes, many of which we've never seen before. Some might be boring, and some might be super dangerous. So what if one such virus finally thawed out? The world would be dealing with a disaster no one has ever seen before. This wouldn't look like a normal outbreak. It would feel more like something out of a horror movie. First, the virus would be totally new and our immune systems definitely wouldn't recognize it. That means the virus would spread crazy fast, jumping from person to person. No one would know what to expect. It could cause weird illnesses, sudden fevers, or even something way more dangerous. Stuff as scary as the diseases people faced in old times. Scientists digging in permafrost already look for traces of those ancient diseases, so it's not impossible. Once it escapes, the virus wouldn't stay local for long. With people traveling everywhere and companies rushing into the warming Arctic for mining and shipping, the infection could go from one small Arctic village to major cities all over the world within days. Hospitals would fill up instantly and doctors and nurses would run out of supplies. Businesses would shut down. Food supplies could crash if the virus hit farm animals or crops. Shipping and travel could freeze completely. Fear and panic would spread around the globe almost as fast as the virus itself. There'd be no vaccine and no cure, because no one has ever seen this virus before. Scientists would have to start from zero. In short, a zombie virus outbreak would be totally unpredictable, and the modern world is certainly not ready for it. Did you know that over the past year, around 150 asteroids whizzed closer to Earth than the Moon? But that's not the scary part. It's that some were only noticed after they flew by. And if even one of those had taken a slightly different path, whole cities would be gone. That's what keeps the scientists worried. The invisible stuff hiding where our telescopes can't see. Let's explore what that means. Astronomers keep a list of asteroids that wander into our neighborhood. If a rock's orbit comes close to Earth, it joins a special club we call Near-Earth Objects, or NEOs. That list can include anything from a harmless little space pebble that wouldn't break a window to a rock big enough to cause an earth-shattering kaboom. NEOs are leftover materials from when the planets were forming. Some of that rubble ended up tucked safely in the asteroid belt between Mars and Jupiter, but some pieces got nudged onto paths that cut across Earth's orbit. Those are the ones we care about, because they're still wandering around today, looping around the sun, and every now and then passing uncomfortably close to us. The biggest objects are the easiest to locate. They are rare and bright enough that they stand out in sky surveys. So far, none of those big ones seem to be heading our way anytime soon. However, the real anxiety comes from the middle class of asteroids. On paper, many of them sit in the potentially hazardous object category, or PHOs, but the nickname City Destroyer explains them better. These rocks aren't huge enough to wipe out the planet, but they could flatten a city and mess with the climate for a few seasons. Some are as wide as a football stadium, and hit the atmosphere faster than a speeding projectile. NASA estimates there are around 25,000 near-Earth asteroids at least 460 feet wide, but we've only discovered a fraction of them. Basically, we have solid orbits for less than half of the city destroyer crowd. The rest only exist as numbers in simulations. We know they should be out there. We just haven't seen them yet. Why are they so hard to spot? Some asteroids are nearly coal black, blending into the cosmic night. Others hang out close to the sun from our perspective, so our telescopes get overwhelmed by brightness. It's like trying to locate a mosquito while staring directly at the sunlight. Please don't do this. From Earth, these rocks are mostly lost in the sun's glare. We only catch a glimpse just after sunset or right before sunrise. And that chance only exists if the sky is perfectly clear and the asteroid happens to be in exactly the right spot. If not, it slips back into the sun's blind spot, playing hide and seek with us. We were caught by surprise quite recently. In 2013, the Chelyabinsk meteor came from the direction of the rising sun. No one saw it in time because it was coming from the wrong direction. It exploded high above the region, shattering windows across the city and sent more than 1,000 people to the hospital. The scariest part is that the meteor was only about 60 feet wide. Now imagine a city destroyer coming from that same direction. A stadium-sized rock stepping out of the sun's glare would give us very little warning, maybe a few days or a week instead of decades. And we know that the blind zone is not empty. Observations have already revealed at least one large asteroid in that region that scientists can seriously consider a planet destroyer. It's called 2022 AP7, and it's huge. This thing is more than half a mile wide, big enough that if it ever hit Earth, it would be a catastrophic day for everyone. Astronomers found it by using the super-sensitive dark energy camera during twilight, pointing the telescope at the region of the sky most surveys normally avoided. The good news is that AP7 isn't headed straight for Earth. Its orbit crosses the orbit of our planet, but the timing doesn't line up, so we won't encounter it this pass, the next one, or even for several centuries. The bad news is what that discovery hints at. If it took this much effort to notice something like this, what else are we missing? And 2022 AP7 is just one PHO. Other asteroids closer to the Sun were also spotted during those same twilight searches. New simulations say some of those hidden rocks are not random. A bunch of them seem to share an orbit with Venus. They do not orbit Venus itself. They orbit the Sun in almost the same lane, sometimes a bit ahead of the planet, sometimes a bit behind, like kids jogging on the same track but spread out along the lap. Astronomers already know about roughly 20 of those Venus co-orbitals, and their paths are anything but stable. Gravity from Venus, Earth, and other planets keep tugging on them, and over thousands of years, those pulls could stretch their paths until they start crossing Earth's orbit. Most flybys are harmless, but one unlucky pass could be the one that counts. So what can we do about this? The first step is simple in theory. Find them earlier. The goal for astronomers is to launch infrared telescopes and get them into space. While we do have amazing telescopes like JWST or the Hubble Space Telescope, they're never pointed at the sun, as the brightness of our star can damage them. That's why we need a telescope in orbit around Venus, or one that travels along with it. It would be in a much better spot to keep an eye on the asteroids that hang out there. NASA is launching the NEO Surveyor project that aims to solve the problem. It should scan the inner solar system to spot dangerous asteroids in time. Also, we're learning that we can actually move asteroids. NASA's DART mission rammed a small spacecraft into a rock, which affected its orbit slightly. Not by much, just enough to prove that it can be done. It's like turning a plane just 1 degree while it's still across the ocean. By the time it reaches you, that tiny change can make it miss by thousands of miles. Teams around the world spend their days babysitting space rocks. And yes, That's a real paying job. NASA has the Planetary Defense Coordination Office. Europe has the NEO Coordination Center. Observatories feed them nightly sky data, and computers immediately check each dot's orbit. If a rock might wander too close, it joins the risk list and gets extra attention. Each new photo updates the orbit a little more. Sometimes that make the danger level rise for a moment. That is exactly what happened with 2024 YR4, when it briefly reached level 3 on the Torino scale before better measurements calmed everyone down. The scale itself runs from 0 to 10, and anything that climbs above 3 is rare enough to raise eyebrows. The whole system works that way on purpose. Notice something strange, collect more data, then decide whether to relax or stay alert. Most of the job is actually pretty dull. It's a lot of number checking, orbit fixing, and crossing out false alarms. That quiet, careful routine is what lets the world respond quickly when a rock finally appears that isn't just passing by. So how worried should we be? For those huge planet-destroying rocks, the short answer is not much. Nothing that size is on the near-term schedule. Smaller city-level threats are trickier. The odds of one hitting Earth anytime soon are still tiny, but they're not zero. Think of it as a cosmic lottery that has been running for billions of years. Every once in a very long while, the universe draws a number that makes astronomers sit up and pay attention. It's not a reason to panic. It's a reason to build better eyes in space and make sure that if a bad ticket ever comes up, we see it in time to do something about it. Australia feels like the safest place on Earth, geologically speaking. No megavolcanoes, no massive fault lines slicing cities in half, no constant earthquake alerts. It looks solid and unbreakable, but according to a brand new global stress map of Earth's crust, Australia is one of the most internally stressed pieces of land on the entire planet. It's not shaking or cracking yet, but it's quietly storing energy like a bent ruler about to snap. To understand why this is such a big deal, imagine Earth's crust like a giant jigsaw puzzle made of moving slabs called tectonic plates. These plates float on softer rock below and push, pull, or grind against each other. Where plates meet, earthquakes and volcanoes make sense. But stress doesn't just stay at the edges, it travels. It builds up inside plates too, like pressure spreading through frozen ice when you squeeze it. Scientists mapped over 100,000 real stress measurements, from oil wells, rock tests, and earthquakes, to see where Earth is being squeezed the hardest right now. When they laid all the data together, the map lit up like a warning sign, and Australia stood out. This shocked scientists because Australia sits far away from plate boundaries, which usually means stability. But instead of relaxing, the Australian continent gets squeezed from multiple directions by nearby plates, especially the Pacific and Eurasian ones. The stress doesn't release easily, so it piles up inside the crust, and then nothing moves. Until suddenly everything does. One of the strangest discoveries showed up in places like the Bowen Basin, where stress directions twist and rotate underground. That's bad news because unpredictable stress behaves like glass about to shatter. These rotating stress fields make it nearly impossible to say when or where cracks could form. It could be years away or tomorrow. And human activity makes it even riskier. Drilling deep into the crust for geothermal energy or injecting fluids underground can nudge these stressed zones just enough to trigger fault movement. This doesn't mean Australia is about to split in half next week. But it does mean the idea of geologically safe might be outdated. Scientists now think Australia could eventually fracture internally and form new fault systems where none existed before. What makes the new stress map different from older models is that it doesn't just explain past earthquakes, it helps identify future risk zones before anything breaks. Countries can use this data to decide where drilling is safer, where tunnels shouldn't go, and where infrastructure needs reinforcement. But even with all this data, we still can't predict the exact moment Earth will snap. Stress maps tell us where the tension is. They don't tell us when it gives up. But this idea of continents quietly tearing themselves apart isn't just theory. Africa gives us the clearest real-world example. It's slowly unzipping itself. So slowly that no human will ever wake up and see a new ocean where land used to be, but fast enough that scientists can actually measure it happening right now. Deep beneath East Africa, the ground stretches, thins, and pulls apart as if the continent is taking a deep breath and never fully exhaling. And over millions of years, that stretch could turn into an ocean. This whole process centers on something called the East African Rift System, or EARS for short. Think of it like a giant tear running through the continent, thousands of miles long, cutting through countries like Ethiopia, Kenya, Tanzania, and Mozambique. It's one of the biggest rift zones on Earth. A rift zone is exactly what it sounds like, a place where the planet's crust is being pulled apart instead of squeezed together. And Africa just happens to have one of the most dramatic examples anywhere on the planet. What's really happening is that Africa isn't one solid plate anymore. It's splitting into two massive chunks, the Nubian plate to the west and the Somalian plate to the east. These two plates are drifting away from each other at a speed that sounds laughable, just less than an inch per year. That's about the speed your fingernails grow. But give that process millions of years and suddenly continents don't look so permanent anymore. In 2018, photos of a giant split in Kenya went viral across the internet. Headlines screamed that Africa was splitting in half right now. It looked dramatic, but that moment didn't mean Africa suddenly broke overnight. That rupture was more like a surface ripple, a small local sign of a much bigger process that's been going on for around 25 million years. And if we could travel in time to 5 or 10 million years from now, we would probably see the crust thin enough for seawater to rush in. When or if that happens, East Africa would slowly peel away from the rest of the continent, and a brand new ocean basin would form between the two plates. Africa would lose its eastern shoulder, and maps of the world would need a serious update. As strange as that sounds, it's actually totally normal for Earth. The planet never stops reshaping itself. It just works on a timeline so slow that our brains struggle to process it. The continents we know today feel ancient and permanent, but they're basically temporary arrangements. About 138 million years ago, South America and Africa were locked together like puzzle pieces. You can still see it if you look at their coastlines. They match almost perfectly. East Africa drifting away will just be the next chapter in that story. Australia's story could follow a different path, but the physics are similar. Stress builds, rock resists, then the rock fails. And stress doesn't care about borders, cities, or how calm the surface looks. That's why scientists are so concerned about something called SH max, the direction of maximum horizontal stress. In simple terms, it tells us which way the Earth is squeezing the hardest underground. If that squeezing lines up with existing fractures, earthquakes become more likely. If it cuts across old faults, new ones can form. Turkey is another place where the stress map practically screams danger. The country sits where Arabian, Eurasian, and African tectonic plates collide. There's also a smaller Anatolian plate on which Turkey is located, and which gets squeezed westward like toothpaste, grinding against massive faults. The stress map shows SH max pointing in directions that load these faults perfectly. Now, researchers looked at ancient lava flows near one of Turkey's faults and realized they weren't random. Lava sheets once flowed smoothly across the land, cooled into solid rock, and then got pulled apart over time, like a snapped chocolate bar. That gave scientists a rare, clear snapshot of how continents deform from the inside out. To date the lava, the team used microscopic zircon crystals trapped inside it. These crystals work like natural stopwatches. They trap helium created by radioactive decay, and by measuring that helium, scientists can tell when the lava erupted and cooled. When they combine that with satellite images and remote sensing, the scientists managed to see Earth's slow-motion movements. The Tuzgolu Fault stretches more than 120 miles and is so massive that you can spot it from space. For years, scientists assumed it behaved like many of Turkey's dangerous faults, where land slides sideways past itself. But this new research flipped that idea on its head. The fault isn't sliding, it's slowly ripping open. The land on either side moves away from each other at less than an inch per year. That sounds tiny, but then again, over thousands or millions of years, that motion adds up to continents literally thinning and breaking. And since the fault sits where three massive tectonic plates meet, this matters way beyond Turkey. All this once again reminds us that continents don't just collide or slide. Sometimes they stretch until they snap. And places that look calm on the surface might already be under invisible strain, inch by inch, year after year, rewriting the map long before anyone feels the shake. Darkness comes right at noon. What is it? The end of the world? Are you getting blind? Is some kind of giant asteroid moving toward Earth? Oh, don't worry. It's just an eclipse, a cosmic event on a planetary scale that isn't scary at all. It's a moment when the moon passes in front of the sun and the planet plunges into darkness for a short time. When this happens, we're not surprised, as scientists usually report on an eclipse several months in advance. With the help of astronomical calculations and mathematical models, they predict the positions of the sun and moon for many, many years ahead. But what happened to people in the past? 100? 500? 1,000 years ago? A farmer goes to work in the field and suddenly the whole area is plunged into darkness. He knows it's morning, but what's happening? Or sailors who travel the seas and oceans and suddenly notice that the horizon and the sky are getting too dark, as if someone had switched off the light. Imagine the primal horror they felt. But in reality, people didn't panic. Even before the invention of computers, giant telescopes, and satellites, people could predict the time of an eclipse in advance. How did they do it? People in the past were much smarter than some of us think. Let's see how they performed astronomical calculations using the example of the Maya civilization and their famous eclipse calendar. So in case you didn't know, the Maya are an indigenous people of Mesoamerica who lived in southern Mexico, northern Belize, and Guatemala. By the way, the word lived is not very fitting. These people are still alive. At the beginning of the 21st century, more than 5 million people spoke 30 Maya languages. Before the Spanish conquest, this civilization was one of the most advanced and complex in the world. The first Maya people appeared here as early as 1500 BCE. By 200 CE, the Maya had already built entire cities with pyramids, courtyards, temples, and infrastructure. The Maya were known for their calendars and astronomical predictions. Many of you have probably heard of the Mayan calendar, whose chronology ended in 2012, so a lot of people thought the apocalypse would start that year. Fortunately, nothing happened. Another Maya invention was the eclipse calendar, which helped these people predict eclipses. For a long time, scientists couldn't figure out how this calendar worked, but now they finally have the answer. It all began with the Dresden Codex, a book from the 11th or 12th century. It has 78 pages made of bark paper and contains knowledge about astronomy, astrology, the seasons, and medicine. It was one of the few books that remained intact after the Spanish conquest of Maya territory. The dates of eclipses used to be very important to people. But why? Did they want to take a day off on that day and have parties? Something like that. Only those parties were scary, dark, ancient rituals. And there was definitely nothing funny about them. The Maya assumed that the moment when the light of the sun was obscured by the moon was some kind of sign from the mythological creatures they worshipped. It was dark in the middle of the day, and the Maya used this time for their sinister rituals. They hoped these actions would please the deities, bringing good harvests, protection from enemies, renewal of nature, or other blessings. We won't go into details. The only important thing is that the Maya wanted to know the dates of the eclipses to prepare for the rituals in advance. For this purpose, they created the eclipse calendar. One of the tables in the Dresden Codex shows 405 lunar months. One such month equals one full orbit of the moon around the Earth, which is about 29 days. The Maya priests used these calculations to predict eclipses for about 700 years ahead. With the help of this calendar, they knew the day of the eclipse. However, modern scientists could not understand how the Maya used this thing. But recently, they found the answer. So, the Maya observed the moon and the sun every day. By observing how the moon moves across the sky, they figured out that it takes about 29 days to pass from one new moon to the next. Then, the Maya noticed that sometimes the moon blocked the sun, and those eclipses didn't occur at random, but in certain cycles. They created a large calendar with numbered lunar months, 1 month, 2 months, 3 months, and so on up to 405 months. During some months, the moon completely blocked the sun, and during others, only partially. The Maya noted exactly which days these eclipses happened. They recorded the moon's position for 405 months. With these notes, they could predict where the moon would be for the next 405 months, and then the next, repeating for hundreds of years. In simple words, they started the calendar anew after passing this deadline. At least, that's what modern scientists thought, but it was a mistake. The moon doesn't orbit the Earth in exactly the same time every month. Some months it takes a little longer, some months a little shorter, just a few hours more or less than the last orbit. Of course, such changes in the schedule were insignificant, but there were many of them, and this made the calendar incorrect. Imagine that you're only a minute late for a meeting with your friends. It's okay. But if you've been running late for 3 months, then you've already got about a 90-minute delay. On the Mayan calendar, which showed 405 months, there were many more of those extra hours. If the Maya always used the last number from one table to start the next one, their eclipse predictions would slowly become wrong. The mistakes would grow bigger each time they reset the table. Instead, the Maya probably began a new table at the 358th month of the old one. In this case, their predictions for when the sun and moon line up would only be about 2 hours and 20 minutes too early, which is very accurate for that time. If we compare the ancient table with what we know today about eclipse cycles, we'll find that this method would let the Maya correctly predict every solar eclipse seen in their lands between 350 and 1150 CE. These small corrections kept the table working well for a very long time. Scientists are sure that with these updates, the table would stay accurate for centuries, with mistakes of less than 51 minutes over 134 years. This shows how advanced Maya math was. It also reveals how deeply the Maya connected their lives and beliefs to the movements of the sun, moon, and stars. We do a similar thing when we have a leap year. February usually has 28 days, but every 4 years it gets an extra day, making 29. Earth goes around the sun not in exactly 1 year, as we usually think, but in 1 year plus about 6 extra hours. Because these extra hours add up over time, after a few years they become a whole extra day. To keep our calendar correct, we add this extra day to the end of February. This day is called Leap Day. This leads to small time errors, so we consider them in a leap year. The Maya did about the same thing with the eclipse calendar. But how did they choose the reference points for their astronomical calculations? We don't know. They did it without computers, telescopes, or other modern technology. They were just very good at observing nature. By the way, a similar system of cycles made people believe that the end of the world would happen in 2012. The Maya created a calendar that began in 3144 BCE and ended on December 21, 2012. The Maya saw this as the date of ending the old cycle and starting a new one. But our modern culture has turned this point into the end of the world. In addition to calendars, the Maya built unique architectural structures. They invented one of the most advanced writing systems. They were also big fans of liquid chocolate. They grew cocoa trees, then plucked the beans, dried, ground, and mixed these crushed beans with water. They warmed it up and got a frothy and very bitter drink. To make it sweeter, they added honey to it, but they could also throw chili peppers and other spices in there. Maya did many interesting things, but this is a topic for another video.
Well, get this. Scientists could bring Neanderthals back to life within the next 20 years. Not as fossils, not as simulations, but as actual living beings. And no, this isn't a sci-fi movie pitch, but a real debate happening right now in genetics labs and ethics panels around the world. The DNA has already been decoded, and the only thing standing between us and a living Neanderthal is whether we should do it, not whether we can. So let's get some things clear. Neanderthals weren't cavemen dragging clubs around as cartoons taught us. They were just like humans, our close cousins, who lived across Europe and Asia for hundreds of thousands of years. They cared for injured members of their society, made tools, wore clothing, and survived scary Ice Age conditions that would wreck most modern humans. Then, around 35,000 years ago, they vanished. No one fully agrees on why. Changes in temperatures, competition with Homo sapiens, health issues, or interbreeding. All of it probably played a role. The reason this resurrection talk even exists is that scientists finished sequencing the entire Neanderthal genome back in 2010. It's like an instruction manual written in DNA, telling a body how to grow, function, and survive. Now, once you have that manual, the question shifts from what were Neanderthals like to could we rebuild one? This is where CRISPR enters the story. It's a gene editing tool that works like molecular scissors. It lets scientists cut DNA at precise spots and replace sections with different genetic code. They already use it to study health conditions, edit embryos in animals, and even modify human stem cells in labs. Now, in theory, scientists could take human stem cells and slowly replace modern human DNA with Neanderthal DNA, piece by piece. One famous geneticist from Harvard says it could happen within a couple of decades. He doesn't mean that copying a Neanderthal straight from a fossil, because ancient DNA is too damaged for that. Instead, his idea is to take human DNA and slowly change it piece by piece until it matches Neanderthal DNA. So it wouldn't be a copy from the past, but a modern human body rebuilt using Neanderthal instructions. Whoa! Scientists are willing to go through all that because they want answers to questions like why Neanderthals disappeared and we survived. How did their brains work compared to ours? Did they think differently, feel differently, or process language in unique ways? A living Neanderthal could answer questions that bones and fossils never can. Some researchers even think this could help modern medicine. Since Neanderthal genes influence immunity, metabolism, and inflammation, studying a full Neanderthal biology could reveal why certain conditions hit humans the way they do today. So, in a strange way, reviving them could help us. But all this excitement hits a wall made of ethics. A Neanderthal wouldn't just be a lab mouse, it would be a person. That single fact flips the entire project upside down. You can't treat a person like an experiment, even if science really wants answers. Being the only Neanderthal on Earth would be tough, to say the least. They'd have to live with no culture, no community, no one who would want to truly share their biology. They'd grow up surrounded by modern humans who would study them nonstop and forever label them as an experiment. So, critics of the idea are sure that kind of isolation could cause serious psychological damage. There's also the issue of consent, which the experiment would completely break. No Neanderthal can agree to being born into a modern world, raised by humans, studied for life, and used as proof of a theory. Consent is crucial in medical ethics, and you can't even test meds without it. Cloning a human ancestor would break that rule. Now, if we forget about ethics, there are also serious biological risks. No one knows how a reconstructed Neanderthal genome would behave in a modern human womb. Pregnancy alone could be dangerous. Development might not follow expectations. Immune reactions could go wrong. Even small genetic mismatches can cause massive problems when you're building a whole human from scratch, And even if everything worked out, the results might disappoint. One individual couldn't recreate Neanderthal society, and behavior comes from culture as much as DNA. Without a full population, the answers we get could be shallow, misleading, or incomplete. The debate on whether we should or should not bring back Neanderthals is so intense because the possibility of doing so is very real. Genetic engineering keeps accelerating, and the tools keep getting cheaper, faster, and more precise. Right now, no lab has approval to try this. No Neanderthal embryo exists. But scientists, ethicists, and state officials already argue about rules, limits, and red lines, which is another proof of how close it feels. It also brings up the big question of whether scientific curiosity has limits and who gets to decide them. Right now, there's no law that bans resurrecting extinct humans. Once one country allows it, others could follow, faster than the rules can keep up. And then, there are scientists who counter all this with a different argument. What if not doing it is also unethical? They point out that we already revive extinct animals, manipulate genomes, and alter life at the deepest level. Understanding Neanderthals could help modern humans survive future climate shifts or mass health disorders. If Neanderthals thrived in extreme conditions, their biology could hold survival clues we desperately need. From that perspective, if we refuse to explore this knowledge, it could cost the world many lives someday. If all this doesn't touch your heart at all because you have nothing to do with Neanderthals, here's a surprise for you. When you look in the mirror, you're probably staring at a tiny piece of one of them. It could literally be in your DNA. According to a study from a couple of years ago, Neanderthals didn't just vanish into thin air, but blended into us. Modern humans, whose ancestors migrated out of Africa, carry about 1 to 4% of Neanderthal DNA. Scientists only have a handful of high-quality Neanderthal genomes to study, just 3 really solid ones. They come from bones found in a cave in Croatia that are about 50,000 to 65,000 years old, plus 2 others from Eurasia dating to around 80,000 and 50,000 years ago. It's not a lot to work with, which means every new discovery matters a lot. Every person has 2 versions of each gene, one from mom and one from dad. When 2 very different groups mix, their offspring end up with more genetic variety. The scientists compared DNA from those 3 Neanderthals with genetic data from about 2,000 modern humans. What they found was shocking. Neanderthals themselves may have carried up to 3.7% modern human DNA. So Neanderthals weren't just mixing into us, we were mixing into them too. Roughly 1 out of every 30 Neanderthal parents may have been a modern human. And this didn't happen just once. The DNA shows at least 2 big periods of mixing. One happened around 200 to 250,000 years ago, and another around 100 to 120,000 years ago. There may have been more, but DNA is like a blurry photo. The older the event, the harder it is to see clearly. According to another recent study, most Neanderthal DNA in modern humans came from one long, intense mixing period about 47,000 years ago that lasted nearly 7,000 years. That's generations growing up together. This lines up with real bones, too. Scientists found skulls about 100,000 years old in Middle Eastern caves that look mostly like modern humans, but with thick brows and other Neanderthal-style features. Sadly, it looks like Neanderthals had a much smaller population than scientists thought. This makes it harder for them to stay genetically separate. As waves of modern humans kept moving out of Africa and mixing with them, Neanderthals didn't disappear, but dissolved into the larger human population. So, Neanderthals didn't lose the game of evolution. They're part of us. It's something worth keeping in mind when you think about the ethical side of bringing back one of them.
Something is about to reshape the entire future of the West Coast. The coastline, the infrastructure, the whole map. Scientists fear there is not one but two big earthquakes coming, one caused by another. This wasn't even on the radar for most people, but new research is changing everything. For decades, everyone treated the San Andreas Fault and the Cascadia subduction zone like two separate monsters that just happened to live in the same neighborhood. They were powerful, yes, but independent. But now, scientists believe these two giant faults are mechanically linked, and one can literally pull the other into rupturing shortly afterward. Cascadia moves, San Andreas moves. San Andreas tears, Cascadia tears. And the potential consequences of that are honestly haunting. Scientists found evidence that it happened at least 10 times in the last 3,100 years. Earthquake, pause, earthquake. It comes from marine sediment cores, which are like time capsules pulled up from the ocean floor. Researchers analyzed layer after layer of seabed sediment and found doublets. Paired debris layers created by two massive quakes happening so close together that the ocean barely had time to settle between them. That discovery takes us to the Mendocino Triple Junction, the geological troublemaker of the West Coast. It's the place where three tectonic plates crash and grind into each other like badly aligned gears. It's also the zone where the San Andreas meets Cascadia, which makes it the perfect place for these double quakes to form. The stress changes caused by a rupture in one fault travel straight through this junction and destabilize the other. It's benign when it happens to a bookshelf. When you move one book, three others shift. But when you think about it like a coastline with millions of people, entire cities, major infrastructure, it instantly feels terrifying. To many people who live on the West Coast, the San Andreas kind of feels like a California's problem, and Cascadia like an Oregon and Washington's problem. But when you understand that these two faults can essentially fire at each other, it stops being a local issue and becomes a continental one. A Cascadia megaquake alone can hit magnitude 9.0 plus, rip open 600 to 700 miles of seafloor, and send a tsunami roaring toward the Pacific coast. And it could just be the first quake, and then, maybe minutes later, the San Andreas snaps in Northern California. The shaking could ripple down the state like a zipper tearing open a jacket, and if it goes the other direction, it could be just as bad. If the San Andreas ruptures first, the intense stress redistribution can destabilize the Cascadia subduction zone. You could get the California quake first with buildings rocking, highways breaking, and power stations failing. And then, soon after, the ocean pulls back in Oregon or Washington. And the 20-minute countdown to a tsunami begins, a follow-up disaster. It's the kind of chain reaction you don't want even in a video game, let alone real life. This discovery also tells us something eerie about the earthquake in 1700, the one that sent a tsunami across the Pacific so huge that it struck Japan with no warning. Japanese fishermen called that wave the orphan tsunami because it arrived without any felt shaking. Only centuries later, scientists figured out that it came from the Pacific Northwest. But until recently, no one knew that the San Andreas might have felt that event too, and it possibly slipped or destabilized because of it. So, the whole West Coast may have moved together. And we've come to the scariest part. All this isn't about if, it's strictly about when. The faults have a rhythm, a pace, and a geological heartbeat. We've seen how they behave across thousands of years. We know what they did, and now we know they sometimes do it in sequence. The real fear isn't the first quake. California already expects a big one. The real fear is the second quake, the one that comes before you've checked on your family, before emergency responders regroup, before the power comes back, and before the dust settles. Even if you don't live on the West Coast, this matters for you too. The ports in California, Oregon, and Washington handle a massive chunk of America's imports. Knock them offline, and it's not just the coastline that feels it. The ripple hits the entire country, and potentially the world. Grocery prices spike, supply chains freeze, gas availability dips, shipping timelines go nuts. The world is much more connected than any of us thought, and a geological double punch on the Pacific coast wouldn't stay a local disaster. It would spread thread by thread, into everyone's life. So, those in power must prepare not for one giant rupture, but for two. Emergency plans, evacuation routes, response times, and power grid designs, all of it needs updating. Because nature has now shown us what even a single major rupture can do to a modern economy. It happened in Japan in 1995, on January 17th at 5:46 in the morning. The quake hit right by the northern tip of Awaji Island, only 12 miles from Kobe, a huge, busy city with about 1.4 million people back then, and another 2.6 million in Osaka nearby. The rupture ripped along the Nojima Fault for about 25 miles. That doesn't sound like much until you realize entire buildings can't survive that kind of sideways shove. More than 5,000 people lost their lives. 43,000 were injured. Nearly 400,000 buildings were irreparably damaged. This disaster hit one of Japan's largest industrial zones. And when you mess with a place like that, the shock doesn't stop at the shoreline. The damage was $200 billion US in losses, from smashed buildings and infrastructure and many businesses shutting down. Kobe's port just collapsed. Only 30% of the Osaka-Kobe railway lines worked. Part of National Route 28 literally vanished into the ground. Schools, hospitals, and municipal buildings, 85% of them took damage or were unusable. Fires broke out across Kobe, almost 300 separate incidents, burning the equivalent of 70 US city blocks and taking another 600 to 700 lives. Almost 100,000 people permanently left the region, 2.5% of the whole population gone in less than a year. And here's a detail that stuck with me. So many bridges failed that engineers suddenly had to confront how poorly older designs handled lateral shaking. Houses with heavy tiled roofs, built to fight typhoons, crumbled because all that weight sat too high. But the newer homes made after the 1981 building code revision stood. And that's when Japan realized that modern seismic standards were crucial to follow. Japan threw $58 billion US into restoring the region. Power came back in days. Roads and rail returned in 5 to 8 months. The main expressway took 21 months. The port was fully rebuilt in just over 2 years. And by then, all debris was cleared. Within 15 months, manufacturing jumped back to 98% of its old level. Stores reopened. By 1999, Kobe's economy reached roughly 75 to 90% of pre-quake levels. Japan overhauled its disaster management system entirely. They set up the Central Disaster Management Council and rewrote building codes. They upgraded everything from emergency drills to fire-resistant city layouts, and they launched the Earthquake Early Warning System that now gives Japan those precious few seconds before shaking hits. The same system that saved countless lives since 2007. But despite all this improvement, the Kansai region still sits on dangerous ground. The Roku-Awaji-shima fault system, the same one that snapped in 1995, still runs under them. The 2018 Northern Osaka quake and the 2024 Noto Peninsula quake reminded everyone that this threat didn't disappear. It just waits its turn. A future large event on that system could hit even harder simply because the region has grown more complex, more interconnected, and more economically loaded. So Kobe wasn't even a triggered double fault rupture, but it still broke a major industrial hub, reshaped a national economy, and permanently changed global shipping routes. That's why when scientists started talking about two joint faults firing off back-to-back in Cascadia and San Andreas, you don't even have to imagine the consequences. We already got a preview in 1995. We've all thought about rewinding time, whether to fix that cringeworthy mistake or a sneak peek at next week's sports scores. But let's be real, those thoughts fade. For most of us, time travel is just a fun movie idea. But for astrophysicists, time travel isn't just sci-fi. It's a serious puzzle hidden in the fabric of space-time. And now, new models suggest the universe might just allow time to bend in ways that didn't seem possible. Humans were intrigued with manipulating time long before complex scientific models. In an ancient Hindu story, a king visits the heavens for minutes and returns centuries later. In a Japanese legend, a fisherman spends days in an underwater palace and comes back to find generations have passed. These are some of the myths that hint that time doesn't flow the same everywhere. And time traveling as a concept didn't just pop up from regret or curiosity, it also came from watching space. Time feels like one constant in our lives. It's always moving forward like a river. It flows forward and it's predictable. But when we zoom out, way outside of our planet, it's a different story. To physicists, time bends, stretches, and slows down depending on how fast you move or how strong the pull of gravity is. And that's not just a theory, it's measurable, proven, and built into the technology we use every day. For example, astronauts on the ISS orbit Earth at 17,000 miles per hour. And their clocks tick just a tiny bit more slowly than ours. It's only milliseconds, but technically, they've aged less. You can see this effect in your everyday GPS as well. Satellites up there feel less gravity, so their clocks tick a bit faster. Imagine playing a racing game where your car and your controller are a bit out of sync. That's why GPS needs constant tweaks, or else your phone would think you are miles away. Gravity also messes with time. Scientists proved it using 2 atomic clocks. Atomic clocks are like the ultimate devices that measure time. They don't tick with gears or crystals, they tick with atoms, the universe's own metronomes. One clock was on a skyscraper roof, the other closer to the ground. The lower one, feeling stronger gravity, ticked just a tad more slowly. The difference was tiny, but it proved that even height can tweak time. Now picture being near a black hole where minutes could equal years elsewhere. This might help you get those mind-bending scenes from Interstellar. So yes, time bends, and scientists know this. And the challenge now is learning how to do it on purpose. Einstein's work proved that time could move differently for different observers. The faster you move, the more slowly time passes for you. This phenomenon is called time dilation. Think of Marvel's comic Flash. He runs incredibly fast, but he doesn't really slow the world down. His own clock runs more slowly, so to him, everything else looks frozen. If you could reach the speed of light, your time would almost stop entirely, while the rest of the universe would keep racing ahead. For decades, physicists believed that was the only path to real time travel. But the Flash is a superhero, and Einstein proved that nothing with mass could reach that speed. The faster you go, the heavier you become, and the more energy it takes to keep accelerating. To actually reach light speed, you'd need infinite energy, because your mass would become infinite too. Since infinite energy doesn't exist in the universe, it's physically impossible. That's why physicists started asking questions like, if time can stretch and bend, could it also fold? In 1994, physicist Miguel Alcubierre posed a question. Could Einstein's math let us travel faster than light, not by breaking the rules, but by bending space itself? His answer was, maybe. He imagined a warp bubble, a region of space surrounding the ship that moves with it, carrying it along like a cosmic conveyor belt. In this bubble, the spaceship itself doesn't move. The space in front shrinks, the space behind stretches, and the ship rides the wave forward like a surfer gliding on a moving sea. Inside the bubble, the ship feels no motion. It's sitting still, but the bubble carries it across huge distances. And because the ship isn't moving through space faster than light, it doesn't break Einstein's rules. The universe itself does the moving. That hypothetical bubble would need a special kind of energy to bend space-time this way. Originally, Alcubierre's equations required negative energy or exotic matter, a substance that's never been found in usable amounts. Early estimates said we'd need more energy than Jupiter could provide. For years, scientists have wondered if the universe could allow something like a cosmic shortcut without breaking the known rules of physics. While nothing practical has been found yet, theorists have explored models that closed time-like curves, loops in spacetime that bend back on themselves. Here's how it works. Imagine spacetime as a giant sheet. Normally, moving across it takes time, like walking across a field. But a closed time-like curve is like drawing a circle on that sheet. If you walk along it, you could eventually end up back where you started. In spacetime terms, the start and end could be different moments in time. So instead of just moving through space, you're following a path that loops through time, a theoretical shortcut to the past. This isn't pressing a button to hang out with your younger self, it's more like a time detour, a loop in the universe that could let something trace its way back to the past, all without breaking the speed of light. Einstein's math already lets spacetime do gymnastics near spinning black holes, twisting like a cosmic corkscrew. Physicists can explore these loops on paper, but creating one in a lab is far beyond our reach. If one day we could turn this math into a real spaceship, a warp bubble wouldn't actually make the ship go faster than light. Well, technically, there would be no speed. Inside the bubble, the ship wouldn't move at all. Instead, it would fold space like a piece of paper, bringing two faraway points together. The ship could get there in minutes while still obeying the cosmic rules. This is how it worked in the famous Star Trek series, and what many movies adopted as a method for space travel. In a hypothetical situation, a warp bubble wouldn't just be for spaceships. You could send a probe, a package, or even a cup of coffee across the galaxy without it actually moving through space. It's pretty cool, because since the bubbles move space around it, everything inside stays totally still relative to the bubble, which means no spills and no weird forces acting on the coffee. However, we are still far away from that point. The challenges we face are pretty massive. We still don't have enough energy, and folding space-time at will is still out of our reach. But for the first time, the math suggests that it's not impossible. What used to seem like pure sci-fi is now popping up in real science journals. These concepts aren't just about whipping up time machines or warp drives. Even if we never pull off a warp drive, figuring out how space-time works is a big deal for understanding reality. For now, it's all theory and simulations, but every experiment pushes the impossible line a little further. Yesterday it was no, today it's maybe. And in science, maybe is where the most exciting things happen. So while we're not ready to build time machines or bubbles across galaxies yet, scientists can now study and test these ideas using real physics, which will lead to new exciting discoveries. That is, unless future Earthlings figure out how to do it maybe 1,000 years from now, so they travel back in time to show us how we can do it ourselves. Which will create a grandfather paradox, unless someone sends the idea back in time and creates a closed time loop. Boom! A fiery rock the size of a skyscraper tore through Earth's atmosphere. It slammed into the ground with unimaginable force and sent shockwaves rippling through the continents. When the chaos finally settled, something strange glimmered on the ground. Shards of glass scattered across southern Australia. But these weren't ordinary shards from your chandelier. They were tectites. That's a fancy name for strange, glassy, pebble-like objects, which are like leftovers from a meteorite impact. Scientists had seen these before. The last batch they found came from a meteor strike that happened about 780,000 years ago, which is already mind-blowing. But this new discovery? Even crazier. These tiny glass pieces seem to be around 11 million years old. And here's the twist. Their chemical makeup didn't match any known impact site. They were totally different, like fingerprints from a stranger. That means they must have come from a completely separate asteroid strike. One so huge, it blasted debris all across the continent. Of course, scientists wanted to find the massive crater that caused all this, but it wasn't as easy as they soon realized. The asteroid might not have hit Australia itself. It could have crashed somewhere hidden, maybe deep under the thick rainforests of Southeast Asia, or beneath the rugged mountains of Papua New Guinea. Over millions of years, the Earth's surface shifted, eroded, and transformed, so it could have covered up the crater completely. Yep, it's like finding a needle in a haystack. All that remains today are these mysterious glassy clues, and wow, those tectites are mesmerizing. Some look like tiny drops frozen in midair. Others are stretched and sleek. Their black, shiny surfaces catch sunlight in a way that almost makes them look alive. But these little gems aren't just pretty. Inside them are traces of silicon, aluminum, and iron. It's all evidence of unimaginable heat, the kind that melts solid rock. I mean molten debris shooting through the air, cooling down into glass before it even hits the ground. That kind of heat. That's how powerful the impact was. The bang must have been enormous, and it spread glittering fragments across hundreds of miles like a cosmic version of confetti. Discoveries like this remind us that Earth has faced more massive asteroid strikes than we once believed. By studying what these tectites are made of, scientists can tell how big the asteroid was, how it hit, and what kind of chaos it caused back then. It's wild to think that the peaceful, sun-baked lands of southern Australia, now home to kangaroos and red dust, were once ground zero for a fiery cosmic impact. If you're waiting for a plot twist where the mystery was solved, I'm sorry. But even with all our fancy satellites and tech, scientists still haven't found the crater. It's like the asteroid hit, left these shiny breadcrumbs behind, and then disappeared without leaving a footprint. Southern Australia now holds these glass shards like a secret diary from millions of years ago, just waiting for humans to piece the story together. Until then, let's visit a couple of impact craters scientists have already pinned down. In the middle of Western Australia, in the ancient Pilbara region, geologists found what might be the oldest impact crater on Earth. It's probably about 2.7 billion years old. Yep, that's billion, with a B. At the time it formed, this gigantic crater would have stretched nearly 60 miles across. Of course, after sitting around for a few billion years, time and weather did their thing. The once sharp crater got worn down and reshaped until it became more like a dome than a bowl. What's left today is called the North Pole Dome, and we can still see about 20 miles of its raised center. To put things in perspective, our planet is around 4.5 billion years old, but most of what we know about meteor strikes comes from much younger rocks. You see, over billions of years, erosion, volcanoes, and plate tectonics have recycled and reshaped most of Earth's original surface. So, finding any piece of crust that old and still showing impact scars is like uncovering a fossil from the dawn of time. Between 4 and 2.5 billion years ago, Earth was totally different. It was completely covered in water, and maybe a few lonely bits of land sticking out. Volcanoes were erupting like crazy. Chemicals were swirling in the oceans, and continents were just starting to form. Most of that early crust got destroyed or buried long ago, so surviving pieces like this crater are unbelievably rare. Then, about 2 billion years ago, Earth went through a wild snowball Earth phase. Ice stretched from the North Pole all the way to the South Pole. But before that icy chapter, something dramatic had already happened in what's now Western Australia. A meteorite came crashing down. This idea fits perfectly with another theory scientists have, that billions of years ago, space rocks were going after the moon, and since the Earth is right next door, it probably took just as many hits. We just lost most of the evidence because our planet constantly reshapes itself. So, a research team went out to North Pole Dome to see what they could find, and after just 1 hour, they struck gold. They discovered something called shatter cones, delicate cone-shaped patterns that form only under the unimaginable pressure of a meteorite impact. You literally can't fake those. Using those shatter cones, the scientists dated the impact to around 3.47 billion years ago. And they think this crater might have been about the same size as the Chicxulub crater in Mexico, the one famous for wiping out the dinosaurs 66 million years ago. That's how massive this ancient strike was. But that's not all. The team also found tiny droplets of molten rock that got blasted into the sky when the meteor hit, cooled down midair, and then rained back to Earth. Some of them even landed as far away as South Africa. Scientists are still studying this crater, so let's leave them to it and hop to our next destination, the North Sea, or more precisely, under it. There's been this mysterious dent in the Earth hiding under layers of rock for millions of years, about 80 miles off the coast of Yorkshire. The crater is almost 2 miles wide. Scientists first found it back in 2002, called it the Silver Pit Crater, and ever since, it's been the geological equivalent of a true crime mystery. Was it caused by an asteroid slamming into Earth, or was it something more boring, like shifting salt beds or an ancient volcano that just sneezed? For 20 years, experts argued about it. But now, after 2 decades of back and forth, researchers finally cracked the case. And the asteroid team wins. Turns out, something from outer space carved out Silver Pit more than 40 million years ago. A research team used super detailed 3D seismic imaging, which is basically Earth's version of an MRI. And they also took old drill cuttings from an oil well from the 1980s. When they put all the data together, they saw the signature shape of an impact crater. It has a raised middle, a ring of broken rock, and even little mini craters left by debris that flew back down after the hit. The cracks in the rocks were stretched apart on one side and squished on the other. It was proof that the asteroid came in at an angle, not a straight shot. Microscopic quartz grains from the drill samples sealed the deal. Under the microscope, they had these weird crisscrossed scars that only form under insane pressure. I don't envy anyone who gets hit by something moving at 9 miles per second, and that's exactly what happened to our planet. Scientists think the impact happened sometime between 43 and 46 million years ago. Back then, the world was warmer and the oceans teemed with life. So you can imagine the chaos it must have caused, though thankfully, no dinosaurs were around to worry about it. They'd been gone for 20 million years by then.
Now, forget about the Kraken and monsters from the deep. I know, it's hard, but try. And you can forget about the Bermuda Triangle and other marine anomalies. They are nothing compared to rogue waves, giant walls of water that suddenly appear and just as suddenly disappear on the sea surface. The destructive power of this phenomenon remained a mystery to humankind for a long time, but it appears that scientists have solved this secret. A rogue wave is a wave that exceeds at least twice all the surrounding waves. If you imagine the world ocean like a video game, then ordinary waves are your opponents. But the rogue one is a super boss. For centuries, hundreds and thousands of ships have gone missing during their voyages. People have made up a lot of legends about what was the cause of marine disasters. Sea monsters, underwater anomalies, mermaids? But today, scientists are increasingly inclined to believe that rogue waves are the main cause of unusual shipwrecks and missing ships. Some believe sailor stories about anomaly waves, while others didn't. But no one could prove their existence. However, everything changed in 1995. When a giant wall of water 85 feet high collapsed on an oil production platform off the coast of Norway. The waves around this monster were 39 feet high. In other words, the monster wave was about the size of a 9-story building, and the neighboring ones measured about 4 floors high. The oil platform wasn't destroyed, but the wave showed it could cause considerable damage to any buildings. Immediately after that, people began to study the phenomenon of rogue waves. However, in the beginning, instead of answers, scientists got even more questions. So, what's so mysterious about this phenomenon? We know how ordinary waves work. What's the problem with finding out the nature of rogue ones? Well, in fact, the difference between them is huge. Ordinary coastal waves are very predictable. They form because of the wind and the uneven landscape of the seabed. Depending on the depth, terrain, distance to the shore, and wind strength, the size and speed of the wave increase. These waves are safe. If they're not big, you can surf. If they are big, then you'll see them in advance and run out of the water, like me. Rogue ones, unfortunately, are almost unpredictable. They can appear suddenly, even during a calm sea. They appear not only on the coastline, but also in the open ocean, like a high-water cliff. The conditions for the appearance of these monsters are very chaotic. When several waves combine their energy into one, it creates a rogue wave. But this process cannot be predetermined or predicted. How is this energy formed? How is it released? And how much of this energy is needed? The questions are too complicated. Now, to try to figure it out, you can place a special buoy with sensors that scan wave data in the water. Then, you need to wait for the rogue wave to appear. And you don't know if it's going to happen or not. Fortunately, it happened off the coast of Vancouver Island. This monster, which was named the Ukulele wave, was 3 times the size of the surrounding waves and had a height of 58 feet. Proportionately, it was one of the most gigantic rogue waves ever recorded. And do you think that buoy with sensors helped to determine the nature of rogue waves? Of course not. It just showed the wave's data. In order to solve the mystery, a group of scientists from the University of Melbourne went to Antarctica, and this time they managed to find something. They brought the most modern equipment for studying weather conditions in water. They installed powerful stereo cameras on the icebreaker SA Augulus II and obtained 3-dimensional images of the ocean surface. Now, observation showed that the formation of rogue waves began when small waves were most susceptible to wind. That is, waves of varied sizes and directions meet the wind, which makes several small waves combine with one large one. It grows faster using this received energy. This is not just a combination of waves, but also their physical effect on one another. Scientists call this nonlinear effects. To get closer to the solution, the scientists also used the fourth-order Stokes theory, which speaks about more complex interactions of waves and their energy accumulation. The theory didn't help much, but it made the whole study more strange. Scientists realized that small waves fed off one another. Then some waves became bigger than the rest and took away all the energy. This process is called modulation instability, and it explains why rogue waves appear so suddenly, as if out of nowhere. Still, scientists admit that even this information isn't enough for them to fully explain these giant waves. Now, long story short, oops, too late, the wind pushes younger waves together, causing them to grow higher and increasing their speed. One wave steals the energy from the rest, and boom! A giant rogue wave appears, looking disproportionately huge compared to the others. It hits a boat, an oil rig, or the surface of the ocean and spills out all that energy. And that's it, silence again. The existence of such a phenomenon has convinced scientists that rogue waves are the cause of many shipwrecks at sea. Now, seriously, think for yourself. When a ship gets into a storm, the captain reports it by radio and makes records in the logbook. But when a ship suddenly disappears from radar without any warnings about harsh weather, then it might have met a giant rogue wave. They're not tied to any particular location. They are sudden and unpredictable, and this makes them some of the greatest dangers in the ocean. So, what do we do now? How can ships, beaches, and oil production stations be protected? How to predict the appearance of a wave? Well, the answer is crest-trough correlation. It sounds incredibly difficult, but it's actually simple. The highest part of the wave is the crest. The lowest part of the wave is the trough. The idea is to measure how closely the ridges relate to the troughs. With strong correlation, waves form in dense groups. There are several regular waves and 1 or 2 large ones in the center. These conditions are ideal for the appearance of a rogue wave. Now, it seems obvious that scientists should use some instruments to measure the troughs and crests on the waves. It seems quite complicated, but in fact, these crest-to-trough correlations can be studied by watching the weather and currents. Scientists hope that they'll be able to predict the appearance of rogue waves using the same systems they need to predict the weather. So, you can take a breath. It seems we're safe. Or not. Given how the weather of our planet is changing, scientists expect an increase in wave height in the North Pacific Ocean. This will contribute to the appearance of giant rogue waves. even bigger than the ones people observed off the coast of Norway. How much bigger? 1.5 times? 2 and 3 times? Well, you better sit down. Scientists conducted experimental studies and found out that these waves can get 4 times larger than previously thought. Could the 85-foot-high wave recorded in 1995 be 4 times taller? It's hard to believe, but let's just imagine it theoretically. A rogue wave with a height of 340 feet may appear in the middle of a storm. This is more than the height of the Statue of Liberty from the pedestal to the tip of the torch. Such a giant wave can pull any ship underwater in a second and easily destroy an oil station. It can throw the Kraken or Megalodon out of the ocean like a stuffed toy. But how is it different from a tsunami? Well, a tsunami is born during seismic activity at the seabed. Such a wave grows, gains speed, and then crashes onto the shore. It's predictable, and you can spot it from afar. So let's hope that scientists will be able to predict the appearance of rogue waves in advance and warn ships not to sail into the risk zone. Ordinary people who live in coastal towns and relax on the beach are also at risk. In the future, they will have to look not only at the weather forecast, but also at the risk of giant waves. For millions of years, something has been lurking in the depths of the ocean. You can't see it, touch it, or map with sonar, yet it keeps entire species trapped where they are. Recently, scientists uncovered its victims, strange jellyfish cousins that look almost identical, except for one odd detail. One travels the world's oceans, the other is stuck in the Arctic, unable to escape. What blocks its way? It's not ice, not land, not even depth, something far stranger. Let's take a look at this mystery. The jellyfish in question belong to a subspecies with a pretty complicated and hard-to-pronounce name, so I won't. See? Anyway, they live very deep in the ocean, about 3,300 to 6,600 feet down. That's so deep that sunlight doesn't even bother showing up there. The strange thing is that some of these jellyfish have a little bump or knob on top of their umbrella-shaped body, and others don't. And this tiny difference decides their entire life story. Jellyfish with a knob are world travelers found across all oceans. Jellyfish without a knob are stuck in the Arctic, like they're grounded for life. To figure out what was going on, scientist Javier Montenegro and his team looked back at more than 120 years of jellyfish photos and sightings. Then they added in modern DNA testing. The results were curious. Genetically, the knobless and knob jellyfish in the Arctic were identical to knob species in the western Atlantic. In any case, this bizarre similarity aside, only the knobless jellyfish are trapped in the north. So, what's keeping them from leaving? It's not a giant underwater wall or a rocky barrier. Instead, scientists think the wall is biological or linked to geography. Just like something called the Wallace Line, nature's invisible border. So, imagine sailing on a boat in Indonesia, crossing from the island of Bali to the island of Lombok. It's only about 22 miles, not even enough for a long nap on deck. Once you're there, the beaches look the same, the weather feels the same, and the palm trees all sway the same way. But when you look at the animals, it feels like stepping into a different universe. Birds, mammals, even reptiles suddenly don't match what you just saw a short distance away. That invisible line dividing the two worlds is the very Wallace Line. The story began in 1859. Alfred Russel Wallace, a British naturalist, traveled through the East Indies. While hopping between islands, he noticed something that didn't make sense. On the western islands, like Borneo and Bali, the animals all look like they belong to Asia – monkeys, tigers, woodpeckers, the usual. But east, the animals seem to have come straight out of Australia. Marsupials, cockatoos, even kangaroo cousins. The two sides weren't blending at all. Wallace realized that a narrow stretch of water could act like a massive biological border. How could two islands, close enough to see across the water, host such different wildlife? The line is not just some quirk of nature, but the result of powerful geological forces. Between the islands, there are underwater trenches that have never dried up, even when ancient sea levels rose and fell. To the west, you can find the Sunda Shelf. That's an enormous sunken platform that once connected Asia to nearby islands. That's why Borneo, Sumatra, and Java are packed with Asian-style wildlife. To the east is the Sahel Shelf. It once linked Australia and New Guinea, helping Australian species spread. The Wallace Line slices right between these shelves. This part of the world, the Indo-Australian archipelago, is where four massive tectonic plates slam into each other. As the seas rose, animals became trapped on islands. When seas fell, some species made it across, but not so many. That's why two islands, separated by just a short boat ride, ended up with completely different ecosystems. The Wallace Line isn't some recent discovery. This invisible border has been messing with animals for millions of years. Now, back in the Pleistocene, when giant mammoths roamed our planet and the oceans were up to 400 feet lower, many of the islands in Indonesia were actually connected. Tigers and elephants could stroll from place to place without ever touching water. But even when sea levels dropped that much, Asia and Australia never linked up. There was always a stretch of really deep water between them, and that watery gap acted like an uncrossable wall. For more than 50 million years, it's been stopping animals from mixing, keeping Asia's lineup on one side and Australia's weird crew on the other. That middle zone of islands, the ones stranded between the two continents, is called Wallacea. Only animals that could swim, fly, or somehow make it across the open ocean managed to live there. Everyone else was stuck at home, no exceptions. As you see, there can be a logical scientific explanation for almost any phenomenon on Earth. Maybe we could find one of those poor trapped jellyfish. Apparently, the problem lies in the North Atlantic Drift. It's a warm current that flows up from the Gulf Stream. Scientists don't know exactly why, but something about this area blocks the knobless jellyfish. One theory claims that predators beyond the drift are too dangerous for these creatures. Another idea is that the knob itself somehow gives jellyfish an edge in survival, but no one really knows. For now, it's like an invisible border. Knob jellyfish pass, knobless jellyfish stay put. On the Pacific side of the Arctic, there's no need for a mysterious barrier. The Bering Strait already does the job. On average, it's only 165 feet deep, which is way too shallow for deep-sea creatures to get through. So these jellyfish, knob or no knob, can't escape south. And since we're back at the topic of animal life, let's speak a bit more about the weird fauna quirks of the Wallace Line, because animals are the easiest way to see this barrier in action. Birds, for example, often refuse to cross even the tiniest gaps of open water, so their species stop right at the line. Mammals are even stricter. Bats can cross because they fly, but larger land animals never made the jump. On the Australian side, it's all about marsupials like kangaroos and possums. You'll also find native rodents that settled there more recently. On the Asian side, you get a different cast: apes, elephants, tigers, cats, monkeys, rhinos. Sure, there are some oddball exceptions. Sulawesi, right in the middle of the divide, has macaques, pigs, and big-eyed little tarsiers. But overall, the split is obvious. Step off the boat, and the animal world changes completely. But then, what about plants? Well, they don't always follow the rules as neatly. Seeds can hitch rides on birds, float on water, or get blown by the wind. But even here, the Wallace Line shows up. Take eucalyptus trees, for example. They're as Australian as kangaroos. Almost no species make it across to Asia. There's just one exception, which somehow popped up on Sulawesi and the Philippines. That's the magic of the Wallace Line. Two islands can look the same climate, same forests, sometimes even close enough that you can see across the strait. But their animals are like night and day. And it's all because of an invisible border in the sea that's been in place for millions of years. Such discoveries might sound small, but they're important. They show us that there are still hidden boundaries in the ocean that humans don't understand. These invisible fences could explain how marine animals spread, evolve, and survive. As scientists put it, finding two different body shapes inside a single genetic family shows how little we know about jellyfish and other gelatinous creatures. As for the Wallace Line, even today, it stands as one of the most fascinating mysteries in biogeography. It reminds us that life doesn't always spread evenly. Sometimes, a short stretch of water can act like an uncrossable wall. There's a lot more mystery in the deep sea than we thought.
In the near future, humans extract ancient DNA from a long-extinct creature. They patch up the missing pieces with genes from a modern-day animal. Then, in a high-tech lab, they bring the species back to life. Sounds familiar? Well, yes, that's actually the plot of the original Jurassic Park. But the thing is, we're now living in the timeline where researchers are doing exactly that. Although this time, the star of the show isn't a raptor or a T-Rex. Believe it or not, scientists at Colossal Biosciences want to bring back the giant moa. Think of it as an ostrich, only twice as tall and way bulkier. It was a massive flightless bird that went extinct almost 600 years ago. The moa once roamed the forests of New Zealand, towering up to 12 feet tall with its neck stretched. This makes it the tallest bird to ever walk the planet. It weighed almost 500 pounds, but funny enough, that doesn't make it the heaviest bird that ever lived. That crown goes to Madagascar's elephant bird, but still, 500 pounds of bird is not something you want running at you in the woods. The giant moa didn't have wings or a beak built for battle, but it didn't need them. For thousands of years, it lived in peace because it had no natural predators, literally being the top bird. Well, almost. The only thing that could take down a moa was the Haast's eagle, a giant bird of prey with a 10-foot wingspan and claws like steak knives. That was the balance of nature, until people arrived. Around the 13th century, the Maori settled in New Zealand, and as humans do, they adapted quickly. The moa, big and slow as it was, became a crucial and probably delicious food source. Within just a few generations, the moa was gone, and not long after, so was the Haast's eagle. No more moa meant no more meals. It's just how nature and survival work. The Maori were skilled hunters, making a life in a new land. But their arrival marked a turning point in New Zealand's ecosystem, one we're still talking about today. The moa wasn't just big, it played a huge part in keeping forests healthy. Now, 600 years later, scientists want to recreate it using cutting-edge technology and ancient clues. But why go through all this effort to resurrect a bird that's been gone so long? Well, according to Colossal Biosciences, the same company behind those gene-edited direwolf cubs that we talked about before, it's not just about the wow factor. They say moas helped shape the landscape itself. In New Zealand, moas helped control vegetation and spread native plant seeds. They kept forests from becoming overgrown and unbalanced. Without them, some plants lost their main seed carriers, and invasive shrubs started to take over areas once kept in check. So the idea is, if we can't rewind the clock, maybe we can reboot the system. Introduce an animal that fills the same job that can help restore what's missing. Okay, but how do you bring back an extinct species? And is that even possible? Well, sort of. But not in the sci-fi clone a complete dinosaur way like in a movie. The original moa has been gone for centuries, and its DNA is damaged, degraded, and full of holes. So instead of making a perfect copy, researchers are going to remix, so to speak. They'll take whatever usable moa DNA they can find and patch the gaps using genes from its living relative, probably the emu. With a tool called CRISPR, which is like a Photoshop for genomes, they'll stitch it all together, tweak the embryo, and grow it in a lab. If all goes well, the result will be something that looks, walks, and stomps like a moa, but not exactly a genetic twin. It won't be a clone, and it definitely won't be 100% authentic. However, Colossal Biosciences says that's fine. If it behaves like a moa and fills the same job in the ecosystem, that's mission accomplished. So no, we're not recreating the past. Not literally. We're building something new that plays the same role. But here is where it gets interesting. Colossal Biosciences seems to be just getting started. They've got an entire extinction comeback roadmap in place. In addition to the giant moa, the company is also working on reviving the woolly mammoth, the dodo, and the thylacine, also known as the Tasmanian tiger. Each one vanished under different circumstances, but the goal is the same: to create a modern version that can fill the ecological gaps those animals left behind. Woolly mammoths were Ice Age elephants. They were befriending ground sloths and shaking the Arctic ground with each step, knocking down trees and flattening snow. During the Ice Age, this region wasn't the frozen wasteland we know today. It was called the Mammoth Steppe, a dry, windy grassland stretching from Spain to Siberia to Alaska, filled with cold, hardy grasses and scattered shrubs. Mammoths helped keep it that way. However, some scientists think that their disappearance may have turned open ecosystems into soggy, carbon-trapping wetlands. So now, the idea is to mix mammoth DNA with Asian elephants to create a fuzzy, cold-loving hybrid that could help the Arctic stay grassy instead of swampy. Maybe even help slow down climate change by keeping the permafrost frozen a little longer. The dodo bird is probably the most famous extinct animal in history. It lived on the island of Mauritius, where it ate fruit and helped spread seeds across the forest. After European sailors arrived, the number of dodos slowly dwindled. It disappeared in the late 1600s, less than a century after it was first discovered, and some scientists believe that its absence had lasting effects on the island's ecosystem. One example would be the Tambalakoke tree, also known as the dodo tree, which might have depended on the dodo to help its seeds sprout. The theory has been debated, but it's safe to say that the dodo had a part in keeping the island's plant life balanced. Now, Colossal is aiming to reintroduce a bird that's similar to the dodo, hoping it can help those forests regrow as well. And then there's the thylacine, my favorite. It's part wolf, part kangaroo, with tiger-like stripes. Despite these strange features, it was a top predator and helped control prey populations in its habitat. But after being blamed for attacks on livestock, it was hunted to extinction. Researchers believe a new thylacine could rebalance nature where things have gone out of hand. So yeah, the MOA might be the headline this time, but it's just one project on a much longer to-do list. However, this is where the big debate begins, because not everyone's on board with this whole bring back a beast plan. While scientists dream of second chances, plenty of people still have big questions. For example, are we actually helping the environment or just poking it with our really expensive science stick? These new animals aren't exact copies. They're mashups. Close enough maybe, but not the originals. Also, ecosystems aren't machines where we can just swap out a part and expect them to work the same. There's also the wildcard factor. A lab-made MOA might not act like the ancient one. It could munch the wrong plants or throw off the balance by outcompeting something that wasn't even around the last time it existed. Some experts worry that tossing new species into today's ecosystem could backfire. After all, the world they're coming back to? It's different. And in some cases, their old homes don't even exist anymore. There's also a deeper concern: the message this sends about extinction. If people believe we can just bring things back, will they take conservation any less seriously? Will protecting endangered species feel less urgent if extinction stops being permanent? So while the science behind all this is undeniably impressive, the ethical questions aren't going away. Should we be reviving species, or should we be doing more to protect the ones that are still here? If both options are true, how do we do so successfully? Whether it's mammoths, moas, or dodos, one thing's clear. We're not just studying nature anymore. We have the power to rewrite it. And like Uncle Ben said, with great power comes great responsibility. Let me know what you think. And as always, stay on the bright side. A huge invisible danger zone is hanging above Earth, messing with satellites, zapping electronics, and giving astronauts a headache. Scientists call it the South Atlantic anomaly, and it's kind of like the Bermuda Triangle of space, because weird stuff happens there and nobody fully understands why. Want to know more about this thing? Well, Earth has a magnetic field that protects us from dangerous radiation from the sun. We'll talk about it later. And over one spot on the planet, right above the South Atlantic Ocean, that shield gets weirdly weak. It stretches over South America and parts of Africa, creating a sort of magnetic soft spot. That weak spot is bad news for anything flying up there. When satellites travel through it, their systems can freak out. Computers freeze, data gets scrambled, and sometimes entire instruments shut down. Basically, the space version of your phone glitching out right when you need it most. Astronauts have to be extra careful in this region too. When the International Space Station passes through the anomaly, radiation levels spike. It's not enough to fry anyone, but it's surely not fun. The equipment can take a serious hit. No one knows exactly what's going on yet, but scientists think the SAA might be a clue that Earth's magnetic field is shifting. If that's true, it could mean big changes for the future, for us all. You see, the South Atlantic anomaly is connected to Earth's molten insides. Deep beneath the surface, the planet's core and mantle are constantly moving, flowing, and clashing. The outer core is a swirling ocean of liquid metal, and the mantle above is hot, solid rock. Under Africa, there's nothing to cool things down. The mantle is hotter than usual, which creates certain instability in the magnetic field above. As for South America, there, the Nazca Plate is dragging rock and debris down toward the core. This cools things off and keeps the field more stable. Such a wild temperature difference seems to be fueling the anomaly. According to some sources, it drives it across the Atlantic. The anomaly is slowly drifting westward. The thing is, Earth's magnetic field protects us from dangerous radiation from space, powerful solar winds, and wild swings in temperature, and keeps our atmosphere in check. But over millions of years, the magnetic poles have flipped. When it happens, north becomes south, south becomes north, and during those flips, the field can weaken. And some scientists thought the South Atlantic anomaly might be a warning sign before a full magnetic reversal. It could mean disaster to humans, but we'll talk about it later. The good news is, these flips take over. On average, Earth flips its magnetic poles about 2 times per million years. That means the next reversal could be hundreds of thousands of years away. Nearly 600 million years ago, our planet's shield almost failed, but at that time, it could have been a good thing. Scientists think this near collapse might have triggered a massive evolutionary boost and helped the first complex life forms to evolve. Back then, during a period called the Ediacaran, the magnetic field weakened drastically and stayed that weak for about 26 million years. With less protection, solar radiation removed lighter gases from the atmosphere, leaving oxygen floating freely in the air and oceans. That oxygen helped the first multicellular oxygen-breathing organisms to see the light of day. Those were strange, squishy creatures that hardly resembled animals today. Some were disc-shaped blobs, fronds, or shapeless fans, stretching over 3 feet long. By the way, one of the earliest known animals, Dickinsonia, was among them. It looks kinda pretty, doesn't it? Now, how do we know all this? Thanks to rocks. They're like time capsules. Tiny crystals inside them preserve the power of the magnetic field from hundreds of thousands of years ago. For example, certain crystals from southern Brazil revealed that 591 million years ago, Earth's magnetic field was 30 times weaker than it is now, and rocks from South Africa dating back 2 billion years showed that the field was at full strength back then. Now, let's explore a bit. Deep beneath our feet, there's Earth's inner core. We're used to thinking about it as a perfect solid ball, but new research suggests it might be changing shape. Over the past 20 years, parts of the inner core may have bulged or dipped by more than 300 feet. That's like a skyscraper popping up or sinking deep underground inside the planet. This core spins independently from the outer liquid core, which creates the magnetic field that shields us from dangerous solar radiation. The magnetosphere is non-negotiable. Without it, Earth would lose its atmosphere over time. Water would vanish, and life as we know it wouldn't survive. It basically keeps the planet alive. Without it, Earth could turn into a barren Mars, which lost its magnetic field billions of years ago, and along with it, almost all its atmosphere. So why is our planet's inner core deforming? It seems to happen where the solid inner core meets the super hot liquid outer core. The molten metal flows around it, and combined with the tug of an uneven gravity field, likely warps its edges. Scientists can't drill down to the core to check this theory. It's 3,200 miles below the surface. But they can track seismic waves from earthquakes as they ripple through Earth. They measure how these shock waves bend, slow down, or speed up, and it can help figure out what the inner core is made of and how it moves. That's probably how they know that the solid inner core is slowly growing, freezing layer by layer of the liquid outer core. But don't worry, it'll take billions of years to fully solidify. By that point, life on Earth would probably already be gone anyway. The sun's gonna swallow our planet long before the inner core stops moving. But let's get back to the topic that, I bet, worries you most. What if Earth's magnetic field just vanished one day? Well, the planet would be hit by a storm of charged particles from the sun. Satellites would start glitching and power grids would go down. We would get zapped with higher levels of UV radiation, the kind that can cause all kinds of serious health issues. In short, it wouldn't be instant doom, but life would get a lot trickier. Luckily, now we know that a magnetic field doesn't just vanish overnight, but ours has been slowly weakening for over a century. So what would life on a planet with a super weak magnetic field look like? You would just have to throw away your compass. It wouldn't point north anymore, just towards the nearest patch of strongest magnetism, wherever that may be. The northern and southern lights would go insane, appearing closer to the equator, all because charged solar particles would be able to get through the atmosphere more easily. Satellites would be under constant attack. Solar particles would fry their electronics, mess with memory, and cause what scientists call single-event upsets. High-frequency radio signals would also get scrambled, thanks to free electrons in the ionosphere. Over time, the solar wind could even start wearing down the ozone layer, leaving us all more exposed to UV radiation. Now, let's decrease the level of drama. A magnetic field isn't the only thing keeping a planet alive. Mars did lose its magnetic shield about 4 billion years ago, and most of its atmosphere got blown away. But Venus has no global magnetic field, but still has a thick atmosphere. If Earth lost its magnetic field completely, we wouldn't instantly vanish, but life would definitely change, and we would have to get used to these drastic changes. Have you ever visited a famous monument and thought, alright, this is boring? While you were up on the Eiffel Tower yawning at the view, another landmark in Paris was pulling off the ultimate plot twist. Hidden in plain sight at Place de la Concorde stands a 3,300-year-old Egyptian obelisk that's been keeping juicy secrets from Pharaoh Ramses II himself. That's right. Ancient secret messages carved in stone have been right under our noses this whole time. Nope, this isn't the next National Treasure movie. This is real life, and it took a real-life Indiana Jones to crack the code. So, let's set the stage. You've probably seen this block of stone before, right? Towering 75 feet high, this massive granite pillar was originally from Luxor, Egypt, and it's been chilling in the heart of Paris since 1836. It's covered in hieroglyphs, and for years, everyone assumed we'd already cracked their code. Mystery solved. Nothing left to see here. Enter Jean-Guillaume Olet-Pelletier, French Egyptologist, cryptology expert, and part-time monument whisperer. Basically, if Indiana Jones traded his whip for reading glasses and binoculars, you'd get this guy. He's got a rather unusual hobby. He strolls up to the obelisk every now and then and casually reads hieroglyphs. For fun. Yes, he can read them fluently. No, we don't know what that says about our own hobbies. Until 2021, experts believe that the inscriptions on the obelisk mainly praise the gods Amun or Amun-Ra, if you're on friendly terms, and Horus, the falcon-headed sky god with those super famous parents Osiris and Isis. But during one of his casual reading sessions, Olet-Pelletier noticed something odd. Some of the hieroglyphs weren't just singing praises to the gods, they were giving directions, literal directions, to the entrance of the temple of Luxor. But wait, it gets even better with a little backstory. Obelisks like this weren't just pretty lawn decorations. They were usually placed at the entrances of major temples, like the Temple of Luxor, where this one originally stood. They symbolized the sun god Ra and were meant to represent a ray of sunlight frozen in stone. Basically, they were giant sacred exclamation points showing off the pharaoh's divine connection and power. Ramses II had 2 of them set up at Luxor's entrance to honor the gods and, of course, to brag about himself. This one got shipped off to France in the 1830s as a gift from the ruler of Egypt, Muhammad Ali. No, not the boxer. And it's been waiting for someone to take a closer look at it. Moving the obelisk to Paris was no small feat. It weighed over 220 tons and had to be transported on a ship built especially for it, called the Luxor. How original. The whole transportation cost the modern equivalent to $19 million. Interestingly, its twin obelisk still stands in Luxor, which means that researchers can compare both structures to see if the story really matches. This pairing of obelisks was intentional, meant to guide the eye and the spirit towards sacred space. Lucky for us, Jean-Guillaume picked the perfect moment to snoop around. The obelisk was undergoing restoration for the upcoming Olympic Games. Scaffolding was up, giving him rare access to the tippy top of the monument. Armed with binoculars and a ladder, he got eye level with parts of the pillars that most of us can only squint at from street level. And that's when he uncovered the real twist. Turns out, ancient Egyptians didn't just chisel random symbols into stone. They had something way cooler up their sleeves: crypto-hieroglyphs. Those were specialized coded forms of writing used for sacred or elite messages. Basically, ancient VIP-only emojis. While your average temple priest could read standard hieroglyphs, crypto-hieroglyphs were reserved for the pharaoh's inner circle. Today, only 6 people on Earth can read them fluently. And wouldn't you know it, our French friend is one of them. Of course he is. Now, here's where things get wild. Normally, hieroglyphs written on monuments like the obelisk are read top to bottom, right to left. Simple enough. But Jean-Guillaume decided to break the rules and read them horizontally instead of vertically. That's when he started spotting weird patterns, phrases, and symbols that had been hiding in plain sight for nearly 200 years. Some of these messages were so cleverly hidden, and you could only understand them if you walked around the obelisk in a certain way. He calls it 3D cryptography. That's right, the obelisk itself is like one giant ancient Rubik's Cube. Depending on the angle you read from, the message could change entirely. Yes, ancient Egypt invented something like the lenticular effect long before Pokemon cards made it cool. Okay, so what in the world does the message say now? Glad you asked. these aren't just random notes from the past. They're political gold. One inscription praises Ramses II as a divine figure who could not be dethroned. Another says the king made offerings to the god Amun, which wasn't just him being nice. This was a big political move. Back then, religion and power were totally intertwined, so showing off your divine connection was like launching a PR campaign, except instead of tweets, they used 200-ton stone monuments. Ramses II wasn't just any ruler, by the way. He reigned for over 60 years and basically pulled off the Beyoncé of pharaonic careers. He won battles, or at least said he did, built cities, temples, and statues of himself all over Egypt, and declared himself a living god. When he ordered these obelisks, he wasn't just creating monuments. He was launching ancient propaganda flyers at priests, nobles, and visiting dignitaries. In fact, Ramses II was so good at self-promotion, he may as well be the original king of rebranding. He claimed victory at the Battle of Kadesh, even though it ended in a stalemate and they had the victory carved into walls and monuments across Egypt. The Luxor obelisk was another way of reinforcing his godlike powers every time someone passed by or read its text. And here's the cherry on top. Some of these inscriptions were positioned just right so they'd be seen by nobles arriving by boat for a festival. That's probably the reason why they can only be read from a certain angle. But if you stood at the base of the obelisk, you wouldn't see much. But from a 45-degree angle standing right in the middle of the Nile, sweet stuff! Imagine pulling up to a religious celebration and seeing giant stone text basically saying, "Hey, Ramses is chosen by the gods, don't forget it." Subtle? Not exactly. Effective? You bet. Some messages even carry double meanings. One line might spell out Ramses II's full royal title. But read it differently and boom! It says he's got eternal life. That's next-level branding. You can almost hear him saying, "Look at me, still trending 3,000 years later." For decades, scholars thought this monument had given up all its secrets, but thanks to new access, modern tools, and some fresh eyeballs, we now know there's still a ton to uncover. Oleg Pelletier's full research hasn't been officially published yet, but the clues he's found are already shaking up what we thought we knew about ancient Egyptian monuments. Of course, not everyone's buying it just yet. Some scholars are skeptical, especially about the idea that boat-riding nobles could actually see those messages clearly. But let's be honest, ancient advertising wasn't easy. Even if your billboard is 75 feet tall, you still need the right angle and the right audience. So the next time you're in Paris staring at the obelisk while sipping your overpriced café au lait, remember, you're not just looking at a fancy paperweight from the 19th century. You're standing in front of an ancient Egyptian PR campaign, a 3D puzzle, and a 3,300-year-old flex from Ramses II himself. And let's be real, if that obelisk had been hiding messages this long, who's to say it's done talking? So grab your magnifying glass, channel your inner Egyptologist, and remember, the real treasure isn't gold or jewels, it's the drama chiseled in stone. It's a perfect summer day. You're relaxing on the beach, dipping your toes into the cool water, when suddenly, bam! A 56-foot aquatic nightmare rockets from the waves. It's the size of 2 London double-decker buses, sporting about 60 razor-sharp teeth, including bonus chompers on the roof of its mouth, because why not? This aquatic beast isn't picky about its diet either. Sharks? Turtles? Other sea monsters? Yep, they're all on the menu. Meet the mosasaur, a group of marine reptiles that ruled the oceans millions of years ago. If you've seen Jurassic World, you'll recognize them as the stars of that epic moment when a massive creature leaps out of the water to snatch a great white shark like it's sushi. That's a mosasaurus, and it's every bit as terrifying as it sounds. Recently, scientists stumbled upon a fossil of one of those marine monsters in, of all places, Mississippi. Yes, Mississippi, the land of magnolias and catfish. Turns out it's also home to ancient sea dragons. This discovery was a happy accident. A team of geologists was mapping the terrain in east-central Mississippi when they noticed something strange poking out of the ground. It wasn't a rock or a seashell. It was a vertebra, and a massive one. In fact, it was so large it barely fit in the hand of the scientist who found it. The fossil likely belonged to the largest known species of mosasaur, the Mosasaurus hoffmanni. Now, the biggest mosasaur ever found clocked in at a staggering 56 feet long. This new specimen hit a solid 30 feet at least, and while it might not break the world record, it certainly makes the crown for the biggest mosasaur ever discovered in Mississippi. Fun fact, that's still longer than the average RV, and with way worse gas mileage. To be fair, the Mississippi Museum of Natural Science already had a couple of mosasaur fossils in its collection. But this newcomer might just steal the spotlight. And this isn't an isolated incident. In 2015, paleontologists unearthed the skull of a 24-foot-long mosasaur in North Dakota. Years later, a private fossil hunter, yes, that's a thing, found an equally huge mosasaur in Texas. Well, its jaw at least. These sea monsters, also known as sea dragons, by the way, actually have one of the wildest origin stories in paleontology. The very first skull was found way back in 1764 in a chalk quarry in the Netherlands. And at the time, scientists thought it was a whale. Then came a second skull, which was so impressive that French revolutionaries literally looted it during the siege in 1794. Legend has it they swapped it for 600 bottles of wine. Doesn't sound like a fair trade to me. That fossil actually helped pioneer the concept of extinction and got paleontologists buzzing for centuries. Since then, mosasaur fossils have popped up all over the world, like ancient scaly celebrities leaving their mark. From the Mississippi backwoods to the deserts of Morocco, from New Jersey to Belgium, scientists have uncovered everything from teeth to full skulls, sometimes even misplacing them in museum drawers for centuries. So what exactly were these terrifying titans of the deep? Well, let's just say, if ancient oceans had a most likely to eat everything in sight award, the mosasaur would win it. Picture a gigantic scaly torpedo with a mouth full of about 60 razor-sharp teeth, including some growing on the roof of its mouth like dental overkill. It had a long, muscular tail for propulsion and 4 paddle-like limbs that worked like turbocharged oars, letting it cruise through warm, shallow seas like a reptilian speedboat. Scientists believe they were close relatives of modern monitor lizards and snakes, which honestly just makes both of those animals way more terrifying. Some mosasaurs even might have had adaptations for sensing vibrations in the water, allowing them to detect movement from a distance, similar to how sharks use electroreception today. Their eyes were well developed too, giving them sharp vision in the dim ocean depths, a key advantage when hunting fast or elusive prey. But what really makes mosasaurs the stuff of prehistoric nightmares is their attitude. They were apex predators, and they knew it. Those sea monsters weren't picky eaters. Fish, turtles, birds, sharks, other mosasaurs. Basically anything that moved was dinner. Fossilized mosasaur stomach contents prove they practiced family dinner in the most metal way possible. If they were around today, your beach day would be a lot more exciting. Probably shorter. These guys were so intense, they dominated the whole world. It's safe to say, mosasaurs were the undisputed rulers of the late Cretaceous oceans. And like today's orcas or great white sharks, they probably used ambush tactics, sneaking up on prey from below before striking with explosive force. Bite marks found on the fossilized bones of turtles and even other mosasaurs suggest intense underwater battles worthy of a blockbuster movie. But how did one end up in Mississippi of all places? Well, rewind the clock about 80 million years and you'll find part of North America underwater. A vast shallow sea known as the Western Interior Seaway split the continent in two, running from the Gulf of Mexico to the Arctic Ocean. It was warm, teeming with life, and yes, crawling with sea monsters. This prehistoric seaway was a watery wonderland. Imagine long-necked plesiosaurs gliding through the water, birds with teeth diving for fish, and oysters the size of car tires clinging to reef-like structures. Even giant fish like this weird guy over here called it home. This ancient inland sea stretched over 600 miles wide in some places, but it was no more than a few hundred feet deep, making it ideal territory for predators like mesosaurs to thrive. The shallow depth also meant that their prey had few places to hide, turning the seaway into a prehistoric buffet. But the western interior seaway wasn't a permanent fixture. As the Rocky Mountains rose, the seaway slowly disappeared. Over millions of years, it transformed from a shallow ocean to swamps and then to dry land. Today, what was once an ocean is now the Midwest, complete with cornfields, cows, and the occasion mosasaur vertebra hiding in the dirt. Now, this wasn't exactly the end of the mosasaurs. Sadly, even these monsters couldn't outswim extinction. Those massive sea beasts met their watery grave around 66 million years ago, when Earth got an unwelcome visitor, a 10-mile-wide asteroid. When that space rock slammed into what is now Mexico's Yucatan Peninsula, it unleashed destruction on a planetary scale. The impact triggered massive tsunamis, set forests ablaze, and shot so much debris into the atmosphere that sunlight was blocked out for months, maybe even years. This impact winter plunged Earth into a deep freeze. With sunlight gone, plants couldn't photosynthesize, and the food chain collapsed like a house of cards. On land, plant eaters starved, and predators like T-Rex soon followed. About 75% of all species on Earth disappeared. But don't think the oceans were a safe retreat. The seas were hit just as hard, if not worse. First came the mega tsunami that devastated marine life along coastlines. Then, the real villain arrived. You see, without sunlight, phytoplankton, those tiny microscopic plants that serve as the foundation of the marine food web, perished. With them went zooplankton, small fish and filter feeders. And when the buffet dried up, the big predators like the mosasaurs went hungry. No food, no future. With plunging temperatures and ocean acidification, even the ocean's top predators couldn't survive. Mosasaurs, along with plesiosaurs and ammonites, were wiped out in the blink of a geological eye. So ended the reign of sea monsters. The good news is that you can now swim at peace knowing that no sea dragon will ever come at you. I mean, it's a bummer that they went extinct, but let's be honest. Beach days are way more relaxing without 56-foot lizards crashing the party.
Stone Age people were grunting cavemen with spears. True or false? Absolutely false. They were gathering around and forming real culture as far as we've discovered. In Turkey, scientists uncovered a 12,000-year-old mystery that's revising history. It's a sophisticated cosmic calendar made out of giant stone temples that may actually be a warning from the stars. We're talking about Gobekli Tepe. This prehistorical site predates even Stonehenge, our classical stone ring circle, by 6,000 years. And it upends why we think Stone Age civilizations emerged and thrived. Here's how this discovery could change our collective history. Around 10,850 BCE, a massive comet, or better yet, a bunch of comet fragments, smashed into Earth. The skies darkened, the temperature dropped, big animals vanished, and it kicked off a mini ice age that lasted over 1,200 years. What's now a place called Gobekli Tepe was home to a group of humans who survived this entire chaotic event. After it happened, they started paying close attention to the sky. As a way of trying to control time a little bit more, they tracked the movements of the sun, the moon, the planets, and comets. This in turn led them to build a huge lunisolar calendar, the first one in the world. Now, if you were to tour around this classic Stone Age monument, you'd see that not all the stone pillars are blank. Some of them have carvings, like this main one with a bunch of V's on it. Turns out there are 365 V's, which scientists believe represent the days of the solar year. One of them, a V hanging on a bird's neck, is thought to mark a solar eclipse. Other pillars have dangerous animals carved on them, like foxes, lions, scorpions, vultures, twisting and crawling up the sides. Unlike typical Stone Age carvings, these weren't of edible animals like deer or sheep. One of the theories is that these drawings were symbolic. Some archaeologists believe they reflect the fears and chaos this civilization had lived through, a kind of collective attempt to make sense of a terrifying and unpredictable world. Archaeologist Danielle Stordur has highlighted the images of vultures, saying they represent the people who passed away. In some ancient cultures, vultures were believed to carry the souls of the deceased into another realm. She's seen similar symbols in ancient sites nearby. To understand why this all makes sense, we need to dig deeper into the real purpose of this site. Gobekli Tepe was discovered in 1994 by German archaeologist Klaus Schmidt, who realized that the hill in southeastern Turkey wasn't just another Neolithic mound. Underneath it, his team uncovered massive stone circles supported by pillars weighing up to 20 tons. Radiocarbon dating puts the site at around 12,000 years old, making it the oldest known ceremonial structure ever built. I mean, it predates the Egyptian pyramids by over 7,000 years. This discovery shocked the archaeological world. At the end of the Ice Age, humans were supposed to be nomadic, surviving off wild plants and animals, not building sacred complexes with symbolic art, and giving birth to what we now classify as civilization. We usually think civilization starts with farming, then villages, then crops. But this site suggests something more surprising. Early humans may have come together not to grow food, but to worship. Schmidt found no signs of homes, hearths, or permanent settlement, just stuff used for rituals and gatherings. This has led researchers to believe that spirituality and communal rituals came first and that farming followed. Because to build something this massive, you'd need hundreds of people working together, which in turn would have sparked the need for food, organization, and social structure. In other words, the temple came first, then the village, then the farm. Now, Gobekli Tepe isn't just stirring debate because it's old. It's because it seems too advanced for its time, and that's where the more controversial theories start to emerge. Some researchers believe the builders of Gobekli Tepe weren't simply primitive hunter-gatherers experimenting with stone tools. They may have been the inheritors of ancient knowledge, remnants of a much older civilization that existed before the end of the last ice age. This idea ties into the Younger Dryas impact hypothesis, a theory that a comet struck Earth around 10,850 years ago, triggering a sudden and catastrophic climate shift. According to this view, the survivors of that event passed down their knowledge through symbolism, architecture, and oral tradition. And Gobekli Tepe could be one of the earliest attempts to preserve that memory. Now, if that's true, then the carvings at this site, especially the animal symbols on the pillars, aren't just decorative. They could be astronomical codes, tracking constellations and celestial events. But one pillar might hold the biggest secret of all. It's called the Vulture Stone, and it's freaking archaeologists out. On it, you'll find a strange combination of figures: a headless man, birds, and a scorpion. To the untrained eye, it might seem random, but some researchers believe these are ancient representations of constellations, like Scorpius among them, and that the headless man symbolizes a mass extinction event. Some even argue that this is the oldest known record of a comet impact, the one that triggered the Younger Dryas. And if you're wondering who this older lost civilization might have been, they are called Atlantis, or more neutrally, Civilization X. Theorists like Graham Hancock suggest that this advanced culture, destroyed in the chaos of the comet impact, passed fragments of its knowledge to survivors around the globe. In that case, Gobekli Tepe wasn't the start of civilization, it was the restart. Now, back to the stones. Pillar 43 may look like a celestial calendar at first, but when archaeologists recreated the sky patterns encoded in its carvings, they found a precise snapshot of the sky dating back over 13,000 years. It appears to show a meteor shower, a flood, and humanity's tragic end, aka the headless man. A snake rising from the ground might even symbolize tidal waves or destruction coming from below. But the story doesn't end there. Pillar seems to expand on the same disaster, the one they called the Terror of the Sky. You might see animals fleeing, waves, fire raining down. It paints a vivid picture of the meteor shower. But wait! While Pillars 43 and 56 may encode memories of a past catastrophe, Pillar 18 might be a forecast. That stone zooms in on the Aquarius constellation. If this sounds familiar, maybe it's from the phase Age of Aquarius, which is the age we're living in now. Some enthusiasts believe this may be a warning for us, and may be telling us that a similar meteor shower will hit Earth and thus you and me and us. I mean, chills! But hey, that's the kind of mystery that makes Gobekli Tepe so captivating. Today, archaeologists know that Gobekli Tepe was part of a much larger sacred complex, now known as Tash Tepler. A network of ancient sites across the region, each with its own secrets and structures, but connected by shared patterns and motifs. In 2019, excavations began at this sister site, just 40 miles from Gobekli Tepe, known as Karahan Tepe. And here's the twist. Some researchers believe Karahan Tepe might be even older. Unlike Gobekli Tepe, which appears to have been primarily ceremonial, Karahan Tepe has signs of domestic structures like walls, tools, and perhaps even homes. And that changes everything. Because whether these sites were the work of highly sophisticated hunter-gatherers or survivors carrying the fragments of a lost pre-Ice Age civilization, one thing becomes clear. Our ancestors weren't just surviving. They were planning, tracking, and predicting. They were far more capable, curious, and connected to the universe than we ever gave them credit for. Kaboom! One huge asteroid could be enough to wipe out all dinosaurs that ever roamed the Earth, leaving behind nothing but a huge crater. Yeah, we're in the Yucatan Peninsula, Mexico, and underneath there's Chicxulub, a massive crater. Now, if there's this immense hole, there must be a meteor too, right? Well, weirdly, no one has ever seen the actual remnants of the space rock itself. It's a bit weird, especially considering how important it is. After all, many think the same meteor that created the crater is the one that wiped out dinosaurs. Now, it might have vaporized on impact, creating a massive explosion. Most of the meteor could have turned into gas or tiny fragments scattered across the atmosphere. Or it might still be here, on Earth, just hiding. And scientists have finally discovered where to look for it. But it's not easy to reach. Around 66 million years ago, a giant asteroid went down and marked the end of the Cretaceous period. It slammed into what's now called Mexico, just north of Central America. The explosion from the impact triggered a global heat wave, which was followed by years of winter. It threw Earth into total chaos. The consequences of this catastrophe led to the extinction of more than 60% of life on Earth, including all the non-avian dinosaurs like T-Rex and Triceratops. It also took down flying reptiles, pterosaurs, and sea creatures like mosasaurs. Long story short, it was the end of the dinosaurs era. But don't be too sad about it, because it paved the way for the rise of mammals, and you and me. Anyway, scientists have recently figured out where the infamous asteroid came from, and where it ended up. The thing wasn't just wandering around Earth's neighborhood. This massive rock might have formed beyond Jupiter and headed straight for our planet. But we'll talk about that a bit later. First, let's look more closely at the collision that created the Chicxulub crater. When the asteroid slammed into Earth, rocks from deep within the planet's crust were thrown up to 15.5 miles into the sky. It also created mountains taller than the Himalayas around the crater's edge. The asteroid itself, called the Chicxulub impactor, was about 6 to 9 miles in diameter. It hit Earth at a speed of around 12 miles per second, coming in at a 60-degree angle. I know we're not in a geometry class, but the angle is important here, since it was exactly right to send the maximum amount of vaporized rock into the atmosphere. As a result, massive plumes of sulfur gases and fine dust shot up, blocking out the sun and causing what's known as an impact winter, which lasted about 15 years. At the time, dinosaurs reigned on Earth. They'd been around for nearly 200 million years before the catastrophe led to their disappearance. The meteor theory seems all plausible, and all the facts add up, but even now, not everyone agrees with that. Some believe that dinosaurs were already on the brink of extinction before the asteroid impact, and the collision might have just sped up the process. Anyway, most dinosaurs were wiped out, but if scientists are right, then those who somehow managed to survive were the ancestors of modern-day birds. So we have an idea of what might have happened, but it took years of studies. The crater was first identified by scientists working for Pemex, a Mexican oil company, in the 1970s. And sometime later, scientists finally realized the mass extinction event that ended the Cretaceous period was because of the Chicxulub. One piece of evidence that pointed to the asteroid were the local fish back then. You see, when the asteroid struck, the immense force of the impact reshaped the planet's surface. For example, it turned rocks into glass-like spherules. Now, spherules are like small spherical particles that can form from the rapid cooling of molten silica droplets. And some of these spherules ended up in the gills of fish that were wiped out by the impact. So, when during another research, scientists studied these fossils, it became obvious to them that the asteroid strike had happened during springtime in the northern hemisphere. They figured this out by studying the lines of growth in the fish's bones. Yep, those can be read just like tree rings. Of course, throughout many years, researchers continued exploring the impact site, hoping to find new data about the catastrophe. Their best bet was to turn to the chemical record left behind by the asteroid, the debris of which is hiding under all those layers of rock and sediment under the Yucatan Peninsula. So they studied the chemical signatures in rocks from the end of the Cretaceous period and found that the asteroid came from beyond Jupiter. And it wasn't just any asteroid. No, it was a carbonaceous chondrite, one of the oldest types of asteroids in the solar system. It most likely formed billions of years ago. These types of asteroids only come from the region beyond Jupiter. So the asteroid that caused the extinction event must have originated there. One of the main clues was ruthenium. It's a rare element in Earth's rocks, but much more common in asteroids. Scientists detected tiny amounts of ruthenium in the rocks, which helped them confirm that the asteroid came from outer space, not from a comet or volcanic eruptions. In 2016, scientists also published the first results from a drilling expedition into the Chicxulub crater. The team managed to drill more than 4,000 feet beneath the seafloor, getting their hands on core samples containing pieces of the original granite bedrock that was struck by the asteroid. These rocks are deeply shocked and placed out of order on top of sedimentary layers. It supports the theory that the peak ring of the Chicxulub crater formed through a dynamic collapse process. Now, about that peak ring, scientists specifically targeted it in their exploration. The so-called ring is a circular ridge inside the crater rim. Similar peak rings can be found in the largest impact craters in our solar system, on the Moon, Mars, and Mercury. But on Earth, Chicxulub is the only well-preserved crater with a peak ring. This discovery also aligns with recent findings from NASA's lunar mission. It showed that the peak rings within the Orientale impact basin on the Moon had formed in an equivalent way to those at Chicxulub. The team is so eager to study the peak ring because they want to test their models of crater formation. Plus, they hope to find out whether this area could have been one of the first habitats for microbial life after the asteroid impact that wiped out dinosaurs. The peak ring formed just minutes after the impact. The deep granite bedrock, initially flowing like a liquid, rebounded into a central tower as tall as 6 miles before collapsing into the ridge we see today. This was followed by a layer of breccia. That's a jumble of rocks and impact melt. And after that, ocean tsunamis brought massive amounts of sandy sediment into the crater. Another find from 2016 was a 10-foot-long core, which revealed bits of granite and minerals from hot, fluid-filled cracks. That was a sign that they had finally entered the peak ring. Geophysicists from the University of Texas explained that they had expected the peak ring to be a large hydrothermal system, and they were drilling to confirm this. The team eventually reached deeper layers, drilling down to 4,380 feet. The team was able to collect most of the core samples they hoped to get, and the samples they got were in great shape. They also gathered lots of useful data from the early Paleocene period and completed a successful scan of the drill hole. Now, scientists from around the world will need some time to fully study and understand what these findings mean. But they're sure that this mission will help answer some big questions, like what exactly happened when the asteroid hit, how it wiped out the dinosaurs, and how impacts like that affect life deep underground. Inside a chunk of diamond smaller than your fingernail, scientists have just discovered something that shouldn't exist. Not just a new material, a new phase of matter, and it breaks the very rules of time itself. The biggest problem is, no one fully understands how it works yet, not even the people who made it. So, let's take a peek and try to figure it out. The story started over a decade ago. Scientists created the first time crystal. Sounds like some mysterious component for a time machine, but it's something even weirder. Take a regular crystal and check it out under a microscope. Like everything around us, it consists of molecules and atoms. What makes crystals special is that their atoms are arranged in a repeating pattern. A salt crystal, for example. If we look at it, we'll see a repeating pattern inside it. And this pattern is the same everywhere, no matter how large or small the piece of salt is, or what shape it is. In the whole crystal, it's unchanged, and it will remain the same no matter how much time has passed. You might also know that all the atoms around us are constantly moving, even at very, very low temperatures when everything freezes and nothing can stop them. Their movement is random, chaotic, and unpredictable. They're just jiggling in space. But time crystals have their own special quirk. Not only are their atoms arranged in the same pattern, just like regular crystals, but these atoms also moved in a looped, endlessly repeating dance. It's super weird. The atoms in time crystals are like an endless dance party. All the guests repeat the same moves in the same order over and over again. The movements in these dances can be basic and simple, or overly complex and chaotic, but they're always looped in time, hence the name. Now, just to clarify, these crystals aren't the kind we're used to. They don't look like gems, diamonds, emeralds, or anything like that. Actually, they don't look like much at all. The beautiful name time crystal describes a new, very strange kind of matter that changes in quantum states, which is what we call the weirdly looped dancing atoms. But even after scientists discovered them, there was something even crazier about them. These dance movements, for some reason, persist even at absolute zero temperature. In all normal materials and objects, if we cool atoms down to such a crazy degree, they would freeze, lose energy, and stop moving. In time crystals, they continue their endless dance as if nothing happened. Oh, and that was only the beginning. Scientists also got stunned because the existence of time crystals seemed to violate the second law of thermodynamics. Now, this law states that over time, any system becomes random and distorted. For example, a warm coffee will distribute its heat and become cold. Ice dropped in the water will eventually melt and unite with it, making water colder, and so on. At first, they thought that time crystals broke this law because it seemed like their atoms can move indefinitely, like a perpetual motion machine. It seemed like not only do they move constantly in the same pattern no matter what happens to them, but they don't need any energy to do so. But then it turned out that they do require energy after all, either from lasers or magnetic fields. So even though they're little marvels, they don't break our physics laws. Yet. There were theories that this stuff could exist. Time crystals were first predicted in 2012 by theoretical physicist Frank Wilczek. Not all physicists accepted the theory at the time. Many believed that the crystals would violate the second law of thermodynamics, which means breaking physics. But the universe really doesn't care what scientists think, and Frank Wilczek won a Nobel Prize for one of his works. Still, some scientists were skeptical about this until time crystals were invented for the first time in 2016. Research from the University of Maryland managed to create one. They did it like this. First, they took a regular crystal and cooled down the atoms inside it to near absolute zero, almost stopping them. Then they started shocking these atoms with lasers. It made the atoms switch between different states repeatedly without absorbing any energy from the laser. You could say that the laser gave them a beat and made them dance by themselves without anyone's help. The result was the first time crystal ever. This was an amazing breakthrough, and ever since then, physicists kept studying time crystals to see what else these guys could do. The biggest problem was that such perpetual motion only truly exists forever in ideal time crystals, and since the time crystals in our experiments weren't ideal, they lasted only a few minutes before they melted and started behaving like regular matter again. But that didn't stop scientists. They wanted to make time crystals stable and usable. In 2021, they made another breakthrough. Researchers at Google collaborated with a bunch of big universities and used Google's quantum computer to create a much bigger and much more stable time crystal. If we manage to implement this property, these crystals could help us get closer to full-fledged, usable quantum computers. One of the biggest problems for this technology was memory. But the loop dances in time crystals might help us store information on a quantum level. That would be absolutely insane. Now, another thing scientists aimed at was a new kind of ultra-precise clock. Time crystals could also help us with that. And now, in 2025, they finally achieved big new successes. They took time crystals even further and created a time quasi-crystal. It's like the jazz version of a time crystal, more complex, a bit more chaotic, yet still coherent and weirdly beautiful. A team led by the researcher Chong Zhu created an atoms dance that was based on the golden ratio, the same perfect number we see in nature in seashell spirals and sunflowers. In most time crystals, atoms dance to a simple beat like tick-tock, tick-tock. In time quasi-crystals, they gave these guys a melody in Phrygian scale over a Fibonacci-timed beat. In simple words, their movements became complex, not looping anymore, yet it still feels like actual structured dance, not random noise. Like a mosaic where no tiles repeat exactly, but still form a wonderful pattern. They started with a tiny chunk of diamond. Then they started hitting it with high-energy nitrogen atoms, knocking some of the diamond's carbon atoms out of place. That left behind empty pockets. Electrons rushed in to fill them, creating little quantum systems inside the diamond. Each of these pockets was highly microscopic, and the final system had over 1 million of them interacting together. Then came the microwaves. Using the magic of 2 overlapping pulses and golden ratio, they stirred the quantum particles into this bizarre, orderly, not looped time rhythm. And just like that, the time quasi-crystal was born. What they got was a stable, non-repeating atomic rhythm in time, something that, mathematically speaking, shouldn't be possible. And it's an entirely new phase of matter. So this isn't just a cool physics trick. It's a doorway into a part of the quantum world we barely understand. Normally, when you pump energy into a system, it either settles into a pattern or falls apart in chaos. But this one did neither. It found a new kind of order. But more than that, it might unlock technologies we haven't even dreamed of yet. Quantum systems like this could be shockingly stable, which is gold for quantum computers. Finally, quantum memory is on the horizon. Quantum computers could use these time quasi-crystals to store data long-term. Next, quantum sensors could use their incredible sensitivity to detect even the tiniest changes in the environment. And finally, the ultra clock we mentioned before, it's coming too. These crystals would help timekeeping devices be ultra-precise. Of course, we don't need this in daily life, but it will be incredibly useful in science. Strangely enough, it turns out that the same fragility that made these crystals difficult to handle also made them perfectly tuned detectors. All this is theory for now, but as scientists continue to study this, some usable tech might not be far behind. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.